Yeah. I thought like
स्टूडेंट्स मैंने ज्वाइन कर लिया है और आप लोग भी लिंक मैंने आपको भेजी है तो उसको ज्वाइन करें और लेक्चर स्टार्ट होने वाला है प्रोफेसर पीटर
dark colored sample, and then that cycles report may not be useful. So that's what I wrote that quite some time back. So I think
Professor Ram Babu Parikh, good morning.
Good morning, sir. Good morning, sir.
Good morning. Most welcome. Most welcome.
Good morning.
He's from Ajmer.
Sir,
Parikh
good
from
morning,
RI
sir.
Ajmer.
Good morning, sir.
yes.
Good morning, Professor Sudha Jain. Sudha ji, good morning.
Good morning.
This is definitely much darker.
No, madam.
Good
morning.
No,
madam.
Good morning.
I have some apprehension with the fibers data which will be generated.
Vasudev, Dr. Vasudev Gurnale. Good morning.
Yeah, I think we have, and it is definitely much taller.
Robotic.
Good morning, sir. Murali from Bangalore.
Oh, Dr.
Yes,
Murali
sir.
Krishna. Yeah.
Good morning, sir.
You can check the samples, if you have a better color sample, we can send it.
I think we should start, I think.
Yeah. Manji,
Sir.
Okay.
start please.
Please start.
Yeah, it is almost 100 now, century.
Very good morning.
Today we have very tight schedule, so yes, yeah. Go.
Sir, can I start?
Yeah.
Yeah.
Mr. Sir,
One minute. Nayan, 1 minute. This Sunny, please mute, so many voices coming out, some, please.
Yes,
let
sir.
us speak.
I was just going to announce that only. I am muting each and everyone. I'm
Okay.
I am providing a force mute. So I have to provide co-host to Nayan Kamal, sir. He's going to be the master of ceremony today.
Okay.
So I'm doing, sir.
Peter Mahaffey.
Yes. Okay. So. Yep. Sir, I have provided course rights to Dr. Mahaffey, Dr. Mishra, Dr. Pare, and Dr. Tamal Bhattacharya.
Yeah. Dr.
Prabhu sir
Biswajit
also.
Saha.
You give it to Prabhu sir also. Prabhu sir.
Prabhu sir.
Yeah, Prabhu sir also. Yeah. Oh, yeah, Dr. Biswajit Saha has joined.
Dr. Biswajit Saha also.
Welcome, sir. He will be the next speaker. Yeah. Good morning, Dr. Biswajit.
Yeah. Now. Good morning, all of you.
Yeah.
Good morning.
Morning, Saha sir.
Yeah.
Yeah, Mr. here.
Yes, Mr. Sir. Good to see you all.
Yeah, Brijesh.
Thank you.
Thank you. Hi, Peter.
Hello.
Should we start, sir?
Yeah, Nayan, start, please.
Yes, sir. You can start. We have started our YouTube live also, and you can start recording also. You can start with this session, please.
Thank you. Thank you.
A very good morning to all joining in this webinar. Respected our keynote speaker, Professor Peter Mahaffy, the King's University, Edmonton, Canada. Dr. Biswajit Shah, Director, CBSE, New Delhi. Professor P. Sivasarup, Regional Director, IGNOU, Nagpur. Professor Javier Garcia Martinez, University of Alicante, Spain. Professor Tom Welton, Imperial College, London. Dr. Ankush Gupta, TIFR, Mumbai. Professor B.B. Prabhu, General Secretary, SCT. Professor Brijesh Pare, President, SCT. Professor Sudha Jain, ex-President, SCT. All members of SCT, other dignitaries and participants. I welcome all of you to the second day of National Convention of Chemistry Teachers 2020, NCCT 2020, and International WebCon on recent advances in chemistry education and chemical research. Today, we have one keynote speech, one special invited speech, 4 invited lecture, and technical presentations. Now, I would like to request Professor Sudha Jain to chair the session.
Saniji, please unmute Sudha ma'am.
Sudha Jain.
Sir, now ma'am can unmute herself.
Thank you, Dr. Nayan. A very good morning to all present here. As this is the second day for this NCCT and this International WebCon. So in this technical session, we are having 3 speakers. One is the keynote speaker, that is Professor Peter Mahaffy. We start with the Peter Mahaffy. So he is Professor of Chemistry at the King's University in Edmonton and Director of the King's Center for Visualization in Science, which provides interactive digital learning resources used by over 500,000 students, educators, and the public from over 100 countries each year. His current research and professional work is at the interfaces of systems thinking in chemistry, education, the uses of interactive visualizations to facilitate the learning of science, sustainability, green chemistry, and the responsible uses of chemistry. With Stephen Matlin, he recently co-chaired the IUPAC Task Force on Systems Thinking in Chemistry Education, and it has spawned a new IUPAC project on system thinking in chemistry for sustainability. Dr. Mahaffy is a past chair of the International Union of Pure and Applied Chemistry IUPAC Committee on Chemistry Education, a charter member of the International Council of Science Committee on Freedom and Responsibility in the Conduct of Science and temporary working group on education and outreach for the Organization for Prohibition of Chemical Weapons, which received the Nobel Peace Prize in 2013. He served on the American Chemical Society Presidential Working Group to help professional chemists communicate climate science to the public. He has co-authored a general chemistry text and 50 referred publications in science and science education. He was also selected as a 3M National Teaching Fellow and has received awards for his work in chemistry education from IUPAC, ACS, the Chemical Institute of Canada, and College Chemistry Canada. I request Professor Peter Mahaffy to please share your presentation. Peter Mahaffy, please.
Thank you very kindly, Professor Jain, for that introduction. Can you see my presentation?
Yes, sir. Your presentation
it's on your screen.
Visible, sir. Yeah.
Good. You know, it's wonderful at almost midnight in Edmonton, when it's minus 10 degrees outside, to see such a warm and welcoming community. Even when you have COVID restrictions, you still clearly are very much of a community to each other, and that warms my heart. So thank you very much for the introduction and for the invitation to join you today. I would like to introduce this topic of how we teach today for the world in 2050. But first, I'd like to get to know you a little bit. And I wonder if I could ask you to use your smartphone or open another tab on your browser and go to www.menti.com, www.menti.com. And I'd like to ask you to introduce yourselves to me. So, menti.com, and use the code 5345194.
So code, may I have the code again, sir, please?
The code is 5345194. I've put it in the chat. I've just put it in the chat.
Yeah.
And I see some of you have found it, 7 of you already.
Yes, sir.
But first, I would just like to know where you are located.
Yeah, India.
So far, I see that most of you are located in India. That's no surprise.
Yeah. Yeah.
So if you found the code, I hope you can keep entering.
Please wait for the presenter to show the next slide.
Yes. I see 23 of you have responded already. There's a few more, I think. And unlike Canada, I think everybody in India has a smartphone.
Yeah.
Okay, I'll show the next slide. And the next slide is, I'd like to know what your professional work is. Are you a secondary school educator, a college or university educator, from industry, government, NGO? Are you a student, or are you a member of the interested public? And this will tell me where you're from and what your background is. This is very helpful. So we have a few people who are from secondary school. That's wonderful. We have mainly college or university educators. We have some students, 4 of you. That's fantastic. And then some of you are from industry, government, or an NGO. Okay, those were the easy questions. Now I have just a couple more for you. If you are an educator, I'm interested in knowing what your primary method of teaching during the pandemic is. Do you teach in person, face-to-face, online mostly, or a hybrid of those two? So some in person, some face-to-face, some online. it looks like almost all of you are teaching online, but a few of you, like me, are teaching some face-to-face with, particularly perhaps with laboratories, and then some online teaching. Thank you for your response there. And then the last question before we dive into things, just a little bit about your background so that I know where you are in terms of your familiarity with IUPAC's work in chemistry education. And this is a scale, so you can select a number. I think I set it up from 1 to 5. Have you used KCVS resources before? Are you familiar with the UN Sustainable Development Goals? Are you familiar with the Planetary Boundaries Framework? Do you integrate sustainability considerations into your teaching? And do you have an idea why I selected the year 2050 in my title? So I'm going to wait just a minute here while you respond to that poll. Okay, and this is what you're telling me. Fantastic. Many of you know of IUPAC's work in chemistry education. I see I have a job to do today to tell you about kcvs.ca. That's good. Familiarity with the UN Sustainable Development Goals and the Planetary Boundaries Framework, and integrating sustainability considerations into your teaching. And then some of you have an idea why the year 2050 is in my title. Okay. Thank you very much for responding. So what I'd like to do today is to organize my talk along 4 lines. I'd like to start with a 10,000 meter view of our world as it is today and as we move toward 2050. And 2050 is the year that we have set as the target for bringing our greenhouse gas emissions down to net zero in terms of the very important Paris Accord. And then I'd like to just talk a little bit about how we educate in chemistry before and after the pandemic, to introduce the idea of systems thinking in chemistry education and the IUPAC project that's focused on systems thinking, and then to tell you a little bit about some resources that we've created at kcvs.ca, which is the visualization center that I direct. Some resources that I think you can take directly into your classrooms to help with the learning of chemistry and also to help connect chemistry to sustainability. So first, the world from 10,000 meters up. What is the world that our students live and learn in today, and how is it changing? Well, the quality of life for many humans has been profoundly improved by the application of chemistry. We know this as chemistry educators. And we also know that our planet, our Earth, and societal systems face unprecedented multiple challenges for Earth and for its people. Are you hearing me okay?
Yes, sir. Yes, sir.
Okay, someone has mentioned that my voice is breaking, but I think it's good on my end.
No, it's good now. Yeah, good.
Okay, good. Let me know, please. And here are just a few of the ways in which we face challenges of ocean acidification, challenges related to the UN Sustainable Development Goals, related to food security, to world hunger, to poverty, many challenges that we face. And 2 of the grand challenges that our planet and its people face are the challenges of the loss of biodiversity. There is discussion about entering a period where we're perhaps facing the 6th mass extinction, where 1 million species currently face extinction. And then maybe one of the grandest challenges of our time is climate change. The fact that it's been 3 million years now since the levels of carbon dioxide in our atmosphere were as high as they are now. In other words, we are looking at a planet that humans didn't exist the last time there was this much carbon dioxide in the air. And the effect of all of that carbon dioxide and other greenhouse gases is not just an effect leading to warming, but this is an important paper in Nature Climate Change that describes 467 pathways for the impacts of climate change on human health, on water, food, economy, infrastructure, and security by climate hazards. And so the question I really want to ask today for your National Convention of Chemistry Teachers is, do students leave the chemistry courses that we teach in 2020 equipped to use their chemistry knowledge to understand and meet the multiple emerging global challenges in our 2050 world, in the world that they will live in when they're perhaps the age of some of us on this call today? So how do we equip them to do that? We can ask the question, why is knowledge in chemistry important for the world of 2050? And perhaps a good start in answering that question is the goal of the UN Sustainable Development Goals, a blueprint for a better and more sustainable future for all. When we look at that goal as chemistry educators, I think we can see that if we build up all of the content pieces in chemistry, they will lead to an understanding of the power and beauty of chemistry in helping to build a more sustainable future for all. We can see the insight as experienced chemistry educator and how all of those pieces fit together. But is that the view of the students in our classroom? The pathway from isolated chemistry facts to chemistry as the blueprint for a better and more sustainable future for all is difficult for many of our students because their vision in our chemistry classrooms is focused on the many potholes, the many barriers they have to traverse in our courses. And here are just a few of them from the chemical literature. This is what many of our chemistry learners experience. And those experiences can obscure the view of the overall goal. And so here are some of the challenges for chemistry education, and they're challenges that impact our ability to equip students for a 2050 world. So while our education in chemistry has changed little in the past 50 years, and you'll hear some more about that from Dr. Javier Garcia Martinez later today, the world is rallying around two sustainability agendas to bring visibility and strategies to address these important global challenges. One of them, which most of you are familiar with, is the UN Sustainable Development Goals, 170 targets to address systems that are rooted in the flow of materials and energy. And we are chemists here and chemistry educators. Can you imagine tackling any of these? Clean water, sanitation, zero hunger, affordable and clean energy, climate change. Without chemistry, it's indispensable. Fundamental chemistry is at the heart of these. And then the second global framework that's driving sustainability agendas is the Planetary Boundaries Framework, coming from two seminal papers, one in 2009 in Nature, a second in 2015, Guiding Human Development on a Changing Planet. And so if you're not familiar with this framework is a framework that articulates, I'm just going to see if I can find a little pointer here. No, it looks like not. It's a framework that articulates 9 Earth systems. And for every one of these Earth systems, there are control variables that describe the state of our planet, the way in which human activity is interacting with our planet, and the extent to which that human activity is threatening that particular Earth system. And so if we look at climate change, here in blue, The blue circle is the safe operating space, where we consider this control variable, if it's below the blue line, concentration of carbon dioxide perhaps in the atmosphere, to be a safe operating space. And we're in a zone of increasing risk. And for several of these Earth systems, like biogeochemical flows and loss of biodiversity, we've left the zone of increasing risk and we're in a zone of high risk. The amount of nitrogen that we have fixed, for instance, is a very good example of that. We're going to come back to that example. And in this 2015 paper, 2 core boundaries have been identified: climate change and biosphere integrity. And they're identified as core boundaries because each of them on their own has the potential to drive our Earth system into a new state, should they be substantially and persistently transgressed. When I first saw the 2009 paper, I read it carefully and I thought, look at these control variables: concentration of carbon dioxide in the atmosphere, introduction of substances like chlorofluorocarbons, concentration of stratospheric ozone, amount of reactive nitrogen. This should be a textbook in chemistry to introduce those chemical control variables, to talk about how to measure them, to talk about how to be sure that we keep them below the planetary boundary. And so as we think about the challenges that our planet faces leading toward 2050, we also now confront COVID. And so for the last 8 months, we have been teaching and learning science through the eyes of COVID. And I'd like to refer you to a paper that we published recently in the Journal of Chemical Education. It was identified as selected as an ACS Editor's Choice publication: Lessons from a Pandemic, Educating for Complexity, Change, Uncertainty, Vulnerability, and Resilience, that asks the question, how do we educate in chemistry? And is that appropriate for what our students experience? And like me, you're probably tired of interacting with students and colleagues only by Zoom. You may be dreaming of getting back to normal quickly. But I'd like to ask you to think for a moment about what normal in chemistry education looks like. And so I went to the literature, looking at what in North America we teach our students in first-year chemistry, freshman chemistry. And I read this: the aim in present texts and in much instruction is a compromise between descriptive chemistry of a few decades ago and the ideas of physical chemistry that have been incorporated for the past 20 to 25 years. The result is an encyclopedic hodge, too extensive for thorough treatment in the time usually allotted, and so rich in multiplicity of slightly related details as to bewilder the earnest student. You know when this paper was published? 1924, the very first issue of the Journal of Chemical Education, when the world was emerging from another pandemic, the Spanish flu, and also from the First World War. So do we want to return to normal? Perhaps not. Perhaps we seize the opportunity of this rupture in our lives to think about what we do as chemistry educators, and we try to move beyond what the normal was. One of the important ways to think about this is to think about the fractionation of knowledge, the breaking up of specialized knowledge into smaller and smaller pieces. This is a statement by Joseph Bordogna, who went on to become the Chief Executive Officer of the National Science Foundation in the US. And he talks about the critical importance of all of the specialized knowledge that we introduce to our students. But then he goes on to say, as we get better and better at specializing, we fractionate knowledge. That's a metaphor that's very meaningful for chemists, for an organic chemist like myself, when we think about taking a mixture and distilling it into its fractions. So if we fractionate knowledge and analyze the pieces in greater and greater depth, is that enough, he asks? What additional skills will be demanded for our world of 2050? And so we have been thinking about that on an IUPAC project. How can we move beyond fractionated knowledge, to consider knowledge that is more holistic in chemistry, all of those important specialized pieces, and help students put them together to address global challenges. And so this project that I'm going to tell you about is a project that focuses on systems thinking, using tools and strategies and cognitive frameworks to look at interconnections and relationships among components of complex and dynamic systems, to examine how the behavior of a system changes over time. When you look at a system, can we understand how systems level phenomena emerge from the parts? The whole is greater than the sum of the parts. And we think that applied to chemistry education, this has some real potential to help our students move beyond looking at a lot of isolated facts, but they were doing back in 1924, to a more holistic view of the discipline and its place in the world. And so this is the IUPAC project. It's called the Systems Thinking in Chemistry Education Project, STICE, asking the question, how might systems thinking applied to chemistry education, and how can that help the next generation address emerging global challenges? This is a project that was co-chaired with Stephen Matlin at Imperial College London, and a remarkable group of 24 people from around the world readily accepted the invitation to try to understand what systems thinking, which is well known in some other disciplines, might mean for chemistry education. And some of the outcomes of systems thinking you may be familiar with already. One of them is a special issue of the Journal of Chemical Education published last December with some 43 contributions. And these came out of the IUPAC project and also some important work by the American Chemical Society Green Chemistry Institute. And systems thinking was featured on the cover of Chemical and Engineering News, which rarely places chemistry education on its cover. So it's attracting some important attention in the world of chemistry and chemistry education. And so I want to just highlight very quickly a few of the important outcomes of the project. Pardon me. The first was to establish a framework for systems thinking in chemistry education, and this was published in Nature Reviews Chemistry. We put the learner in the middle of that system, and then we identified 3 nodes or 3 subsystems that we'd have to understand if we want to think about learning in chemistry in the 21st century. One is what we know about how students in general learn. What are the theoretical frameworks of learning, the social context for learning? And then what are some of the unique challenges of learning chemistry? And finally, what are the elements of systems thinking that orient chemistry education toward meeting societal and environmental needs? And then building on that framework, the task force worked for a period of 3 years, and my colleague Mary Kay Orgill from the United States articulated some essential features of systems thinking. One is that a system is a whole, not simply a collection of the parts. The second is a focus. Systems thinking involves a focus on how the relationships among the parts cause system behavior. A third element is a focus on how a system changes over time. And fourth, what emerges when you look at the whole system and how the parts interact with each other? Are there new understandings? And I'll give you an example of that. And then finally, how does that system interact with its environment, including humans? I don't have time today to go into detail about systems thinking, but I'd like to invite you to join an ACS webinar on December 10, where Mary Kay and I will be unpacking much more carefully what systems thinking in chemistry education means. One of the things that we did in the project that I think is quite useful is to develop some concept map extensions, some way of visualizing chemical systems and their connections to Earth and societal systems. And so we've developed some tools that are called SOCMEs, System-Oriented Concept Map Extensions, tools to zoom out from the narrowly specialized chemistry that we teach and to visualize interconnections. And then we can set some boundaries of focus because systems, of course, are big based on the learning outcomes we have for a topic, a course, or a program. And this can really help to see emergent behavior and change over time, cause-effect relationships. Let me give you one example that we've developed from the chemistry of reactive nitrogen. If I were to ask you what the most important technological invention of the last century, of the 20th century was, could you just drop into chat what you think the most important technological invention of the 20th century is?
Yes.
What do you think? Thank you, Jaya.
Bonhoeffer. What is Bonhoeffer? Hydrogen synthesis.
Great answers that you're giving.
Yes, sir.
When I ask in North America, do you know what everybody says? Computer chip.
Yes, sir.
So the most important technological invention of the 20th century, and Vaclav Smil, a Canadian, was in a debate with, I think it was one of the computer chip folks about 20 years ago as to what the most important technological invention was. And Vaclav Smil suggests that it is, as many of you have suggested, the Haber-Bosch process, the process of making ammonia, making bread from air. And he says, without the Haber-Bosch synthesis of ammonia now 120 years ago, about 40% of the world's population would not be here. So an important chemical reaction. But how do we educate about this reaction? Stop and think about that for a moment. Here's that core reaction, H2 plus N2 creates ammonia. And in North America, in general chemistry textbooks, this reaction is introduced in a chapter on equilibrium. And we give equilibrium, mathematical relationships around it. We talk a little bit about it in the context of kinetics. And that's about the extent of it. We don't talk about the fact that 40% of our planet's people are here because of this reaction. So what would happen if we were to teach the Haber-Bosch process with a systems thinking framework? If we were to zoom out from that N2 plus H2 gives ammonia reaction and start to see some more connections. And so this is some work that I have done together with Tom Holm, the editor of the Journal of Chemical Education, and Stephen Matlin in Imperial College, and a Canadian colleague, Mark Whalen. And we've developed one of these SOCME, System-Oriented Concept Map extensions for the Haber-Bosch process. And it comes from asking questions like, well, where do the starting materials come from? And what conditions are needed for this reaction? And what are the energy inputs? About 2% of our planet's energy is actually used to make ammonia in the Haber-Bosch process. And why do we make it? Well, it's part of the Oswald process system. We're making things like nitric acid, and we're making them so that we can fertilize crops, but also so that we can build explosives. And then ammonium nitrate has not only these intended uses, but unintended consequences, eutrophication of water, health effects, and so on. And so Tom has developed a very interesting visualization of saying, if we look at all of these different subsystems, the energy input, the chemical inputs, the core reaction, the Oswald process, and then these intended and unintended uses, we can now see a system involving reactive nitrogen, and this was written up in the Journal of Chemical Education. And we can see by looking at that system some phenomena that emerge. How is it that looking at reactive nitrogen as a whole, going beyond what we usually do in our classrooms, we can help students understand, for instance, the reactive nitrogen biogeochemical flows, the fact that we've far exceeded, we're in a zone of very, very high risk for the amount of fixed nitrogen that we have. Or how can we see the role of fixed nitrogen in so many of these UN Sustainable Development Goals? And some of the details of that are provided in that reference in the Journal of Chemical Education. And as a working group, we've developed a concept that we think is quite important. It's a concept that exists, a term that existed in the literature, It's called The Molecular Basis of Sustainability, and it was first published by Paul Anastas and Julie Zimmerman, who identified the fact that many environmental issues have molecular considerations. So we've tried to develop that further, and I'd refer you to this paper in Nature Sustainability last year, Systems Thinking for Education, about the molecular basis of sustainability. The flow of material and energy is integral to all aspects of society and the environment. We know that as chemists. And in fact, our job as chemists is to understand and control matter through activities to analyze, synthesize, and transform substances. So we have a special responsibility to address the sustainability of Earth and societal systems. And the molecular basis of sustainability we define as the ways in which the material basis of society and economy, the things that chemists do, underlie considerations of how present and future generations can live within the limits of the natural world. And we think this is an incredibly important but largely invisible aspect of global sustainability agendas like the UN Sustainable Development Goals and the Planetary Boundaries Framework. We don't hear those engaged in those frameworks often talking about the molecular basis of sustainability. And in our chemistry courses and programs, we don't often enough talk about the molecular basis of sustainability. And so if we think ahead to the world of 2050 that we are equipping our students for, shouldn't developing the capacity to understand how chemistry knowledge can equip our students to live within the limits of the natural world be a central learning outcome for our courses, for our degree programs? And how can we reimagine current practice to do that? And so the systems thinking in chemistry education project has ended now, just at Christmas at the beginning of the new year, with some suggestions for things that we need to do to move ahead with systems thinking. We need to resource chemistry educators and students. We need to do some chemistry education research related to systems thinking. And we need to examine who benefits from a systems thinking in chemistry education approach. And just a quick little note that we've just launched last month a second IUPAC project that builds on the success of this first one. It's a new task group. It's entitled Systems Thinking in Chemistry for Sustainability Toward 2030 and Beyond. And systems thinking has been identified as one of 5 key competencies as essential for a sustainable future. So we ought to be incorporating it into our chemistry courses. And there are 3 strands to this new project. One is focusing on chemistry as a sustainability science, and we're engaging with the International Year of Basic Sciences for Sustainable Development in 2022. And yes, the large use of fertilizers is absolutely not sustainable. We're developing recommendations to guide the use of systems thinking in chemistry education, and we're discussing with the Committee on Chemistry and Industry ways to bring industrial perspectives the idea of systems thinking. Very ambitious and very important project. So let me conclude with introducing you to some classroom-ready resources that the group that I work with, which is a group largely of undergraduate students and a few colleagues, that are designed to assist you in visualizing important concepts in chemistry, and also to interconnect chemistry topics with sustainability considerations and to support systems thinking approaches. The King Center for Visualization in Science, here's the group that was working this past summer. We had to work remotely because of COVID. We're a research and dissemination center of the small university that I'm at in Edmonton, Alberta, Canada. We were founded 15 years ago. Everything that we produce is rigorously peer-reviewed by both scientists and educators, so it's trustworthy. Even more importantly, all of our resources are free, and we have about 500,000 unique visitors a year from 110 countries. We develop partnerships for research, development, and dissemination. So just write down www.kcvs.ca for all of the links that I'm going to show you a couple of things right now. And perhaps one of the hosts could put www.kcvs.ca into the chat for everybody. So here are a couple of examples, just a few. We have over 100 visualizations, but I'd like to just take a couple of minutes and give you a flavor for what we've produced. Leading up to the International Year of the Periodic Table, we worked with the isotope scientists and also educators at IUPAC to create the interactive electronic periodic table of the isotopes and elements. We've just worked with the Stockholm Resilience Center in Sweden to create a resource called the Planetary Boundaries Framework. We have 3 sets of resources that link climate change to what we teach in chemistry. The first of these is a resource that was created for the International Year of Chemistry called explainingclimatechange.com. And if you go to kcds.ca, you'll find all of these there. The second is the resource that is designed specifically to relate 5 topics that we teach in chemistry to climate literacy. And the third is a very hopeful simulation that helps us figure out how we get to 2050. And it's possible to get to 2050 to net zero as a planet with currently available technology. But let me just show you a couple of these in the little bit of time that I have left. So a quick question for you first on Menti, if you can go back to Menti for just a moment. And the code is 5345194. 5345194. Maybe somebody could put that in the chat. I'd like to know the approximate age of the last periodic table you've seen hanging on a wall, maybe in your classroom, maybe in your office, maybe in your university or high school. How old is it? Is it more than 30 years old? Is it 20 to 30 years old? 10 to 30 years old? Less than 10 years old? Or nobody's going to answer, what's the periodic table? A group of chemistry educators here. Okay, so keep your answers coming. And I have a little task for you. I want you to imagine that you're back in secondary school. This is what I looked like when I was in secondary school. And one of the things that you might have been asked to do is to calculate the molecular weight of methane. So I'm going to give you the data from the periodic tables. And you might just want to write these 2 numbers down. The atomic weight of carbon is 12.0107. And the atomic weight of hydrogen, so 12.0107. In the chat for you. And the atomic weight of hydrogen is 1.00794. I'd like you to do a quick calculation, pretend you're back in high school, and calculate the molecular weight of methane. Okay, you have those numbers written down. You're back in high school, remember, secondary school. And so what's the molecular weight of methane? What did you come up with? And of course, you'd use the correct number of significant figures. So the unit molecular weight is 16, and if we use the correct number of significant figures, you're going to come up with 16.0425. Okay? So pretty straightforward. But now imagine you're a secondary school student today, and you use the values on any IUPAC periodic table that was created after 2009. And this is what you're going to find when you look at that periodic table. It's going to say carbon, 12.00, 12.02, hydrogen, 1.007, 1.009. And you're going to put up your hand if you're a student and you're going to ask, Professor, what number do I use? And so on the periodic tables that have been created since 2009, the atomic weights of carbon and hydrogen are not constants of nature. And so a very important publication came out a year and a half ago by a working group of isotope scientists. And it shows the variation in atomic weights of carbon depending on where those carbon atoms come from. There are so many processes in nature that involve the fractionation of mass. And so you can tell whether your carbon atoms came from carbon dioxide molecules in air or carbonate ions in the water or methane in the air because they have different atomic weights. And so we've built an interactive visualization at kcvs.ca that allows you to select the element carbon and to simulate its mass spectrum. And of course, the carbon atoms that we know of, 99 of them out of 100 have the isotope carbon-12. And if you run this simulation a few times, you're going to find that one solitary carbon atom is going to have a C13. The mass spectrum is going to look something like this. But what we've done is to set this up so that you can change the rules of the world a little bit and in fact understand how the world works. So what if carbon-13 was about 7% instead of 1%? What would the mass spectrum of those carbon atoms look like? And you can see that we'd still have C12 and we'd have C13, but you're going to now start seeing some more C13 atoms. And if you run the simulation enough times, on average, about 7 of them are going to be C13s. So this is an example of one of the interactive tools that we've created to help with understanding why carbon atoms and hydrogen atoms have atomic weight intervals. And so I'd encourage you to go to kcvs.ca to look at the interactive periodic table of the elements and isotopes, to click on carbon, for instance, and you'll see the intervals of atomic weights for carbon. You'll see, if you click for more information, you'll see that carbon actually has 15 isotopes and some applications of those isotopes in biology, applications in earth and planetary science. Here's the full range of atomic weights of carbon for different sources of carbon, isotopes in forensic science and anthropology, and so on. And so one of the things that you notice is the periodic table looks very different. And I hope some of you will print this out. It's on the IUPAC website. And you'll see that the colors represent whether the element has 2 or more isotopes. The atomic weight is expressed as an interval, or perhaps a single number because we don't know yet what the intervals for atomic weights are. And along with this, we've created at KCVS a set of interactive resources that introduce you to isotopes, to key ideas that relate to stable and radioactive isotopes, that tell the story of Ötzi, the Iceman found in this melting glacier in Europe, and how we can tell actually where he grew up and lived based on the isotope ratios in his body. And I will wrap up here in just a moment. I want to just mention a couple of other resources. I won't take time to go through them. This is our most recent one, that planetary boundaries framework that you saw. We've developed this in conjunction with Sarah Cornell and her colleagues at the Stockholm Resilience Center. And what you'll find if you go here to come back to the biogeochemical flows, here are the 9 Earth systems. And we can see as we go from 1900 to the present, how the control variables for each of those Earth systems have changed. They've gone from low risk to regions of higher risk to regions of very high risk. If you look at the biogeochemical flows that we talked about earlier, you can see that, yes, we perhaps keep 40% of our planet population alive with nitrogen fixation. But back in 1970, we passed the safe space in terms of the amount of fixed nitrogen, and we've also passed that phosphorus biogeochemical flow. And if you go back to the main Earth systems here, if you hover over one of them, you'll see the connections that it has to other Earth systems. The process is described, the connections are described, and we're developing some curriculum connections. So I won't go into these last three resources, but if you're interested at all in the connection between climate change and chemistry, there are three rich resources for you, some of which have been published already and some we are developing. The one that you would, I'd really like you to play with a little bit is this one, which is Design Our Climate. It's going to show you how you can use currently available technology to bring down greenhouse gas emissions to achieve the massive problem of moving from our current trajectory down to net zero by doing things like implementing solar and wind alternative energy, by bringing in changes to the way we drive and transport each other and changing fuel consumption. Every one of these makes little incremental changes, and you put them all together and you can actually achieve net zero by 2050. It's not easy, but you can get there. So what I've tried to do today is to give you this 10,000 meter perspective on our current world and the world that our students enter in 2050. Talk just a little bit about the pandemic and what our students experienced during the pandemic, and how we need to rethink what's normal as we go back to teaching after the pandemic is over. Can we integrate sustainability and systems thinking into our teaching? And can you make use perhaps of these resources that we've made available? I'd like to end by thanking the IUPAC Systems Thinking and Chemistry Education Project Steering Group and the Earth and Societal Systems Node, my undergraduate students and colleagues at the King Center for Visualization in Science, particularly Rob McDonald and Melanie Hoffman, who developed the Planetary Boundaries Framework and Design Our Climate. And I'd like to thank my colleagues Vicente Talanquar in the US and Bob Bucat and Roy Tasker in Australia for their work co-authoring this article in Education. And I'd like to thank each of you and every one of you for joining me today for this presentation. And I think I've probably gone too long, so there may be no time for questions, but if you have questions, I would be very happy to try to.
Thank you, Professor Mahapi. I think we may have one question. If anyone asks. No question.
Audience, if you have any question, you can just raise your hand. Then I will be unmuting.
Or you could put your question into chat.
Chat. I think no question. So I think there is no question.
No question, sir. Ma'am, we can continue.
So, Professor Mahapi,
yes,
we would like to thank you very much. You have very good interactive start by this, just taking us to the chat box, and then you ended with interactive periodic table, the IUPAC periodic table. Again, you took us for question answer session. That is real interactive session. And you have very well clarified the system thinking in chemistry education. That is, it is the IUPAC process. And you took the very simple example, Haberbosch, and you explained total how system thinking can be started, how it can be done. And then you have very well at large explained about the sustainability developments, what blueprints for the betterment should be taken out, and what global sustainability frameworks have to be designed. Really, we are thankful to you for your informative session. Thank you very much.
Thank you very much. It's been a pleasure to be with you.
Our next speaker is Professor Vishwajit Shah. He is Director Training and Skill Education, CBSE. New Delhi. He manages the works of skill curriculum design, development of student resource books, and training manuals, and monitors the execution of various teachers' training programs by 16 CBSE Center of Excellences. He also represents CBSE in various national and international committees. Prior to joining CBSE in 2011, Dr. Saha was faculty member and HOD CSE at Government Engineering College, Agartala, served as OSD Technical Education, Government of Tripura, and worked with Tripura Central University and NIC, Government of India, in various capacities. Dr. Saha handled execution of various development projects of World Bank, AICT, UGC, and MITY. He had actively participated in the drafting of NVEQF, NSQF notified by MHRD and MSD in 2012 and 2013 respectively. He drives promotion of future skill in schools and strong industry association and oversees digital education movement under Vidyadan at the Red Diksha. Now I invite Dr. Bisjit Saab for the presentation. Professor Bisjit Saab, please.
Thank you and namaskar. I think after Peter's presentations, I was just again thinking whether I am fit for any sort of discussions or conversations in this August forum. The way he presented, and of course, from the very first day, and again tomorrow, there are so many dignitaries are going to present. So actually, I thought after getting that invitations, I thought of it would be a learning experience for me rather than delivering anything, because these conventions of for chemistry teachers across India and the participations of experts from different part of the country and of course the different part of the globe, it's really encouraging. So my compliment to SET for inviting me because I'm getting the opportunity to learn here. So all dignitaries, of course, all the office bearer of SET, it's a great thing that you have organized such a international level of conventions where our teachers who have joined through different social media platform, and some of them are very much directly present here, is going to get the different kind of flavor. And as such, from the Peter's presentations, I can say that the way the chemistry is evolving, and by 2030 with reference to SDG and 2050, how actually we are going to think. Now, my submissions to this August gathering is related to the school educations majorly. And of course, certain things I would like to highlight with reference to the higher education. Now, as a teacher, when the subjects are being taught in the classroom, the way, again, I am really becomes fan of Professor Peter, the way he started is giving an opportunity to understand the level of competency of the participant. How many of us are really doing these kind of activities before starting a session in our classroom? That is understanding the student level or understanding how students are going to learn with you. So this parameter, in many of the case, it is missing, but of course, certain percentage of teachers here in India also are doing effectively to manage the classroom. Now, this thing is the way we are supposed to conceptualize, one way, if we look into the new education policy, where that competency based learning or learning outcome based is rather focused in a way so that we all can derive certain level of learning outcomes with reference to a particular grade. Now, this competency would be unfinished unless and until a teacher is going to connect him or her with the real life. So my submissions to all the eminent teachers, especially who are involved with the school chemistry teaching, that real-time connectivity is very much essential at this stage. No matter how and what way 21st century skills are being evolved or going to be evolved, but these things fundamentally require to be corrected in our classroom. So first one is understanding the level. Then second one is that how we are going to connect them with the real life. Now, of course, there is a huge requirement of your involvement, especially not only with the subjects, finding the real-time examples which you can create or weave a story on day-to-day basis in your classroom so that each and every student are going to be connected with you. And already there are a lot of works has been carried out by different teachers across the globe. Now, first and foremost one is you have to fetch these things. And from the side of CBSE, we are also trying to provide a lot of informations through Diksha app as well as the Diksha platforms available in web domain. Now, how many of you are really accessing it and also giving this to you? It becomes a competent one. And with reference to the resources, again, I'm sorry to mention here that most of us are closely depend on the textual material, be it from the NCERT or from other publishers. Now, whether any subject teaching can be confined within the boundary of a textbook, or it should be given a boundary, a horizon where child can explore his innovative thinking with the real life. So again, my request that connections need to be established so that each and every student can cater their potential requirement, not in terms of only joint entrance exams preparations. Now, first and foremost thing is how one comprehend his or her body while learning chemistry. So there are a lot of examples. I am not a subject expert, so I am not going to, but maybe a simple examples if I like to quote here. How much heat a human body dissipates. Now, of course, there are certain level of physics, certain level of mathematical calculations. If we consider the body shape, maybe in terms of cylinder or maybe some other shape. So all those things are actually gearing up a bond between the student and teacher. My second agenda is with reference to assessment. Many a times, assessment, whatever we have institutionalized, be it secondary level board assessment or formative assessments, we are catering in schools by individual teachers. So this assessment is again need to be shifted from rote-based to a competency-based one. Now here, one way, the answer always in case of competency-based assessment, The answer given by one student, individual student, will vary with the other student. But we feel a standardized answer. We want a standardized answer. So that means, where is the originality? Of course, at certain level, if it is a definitions or some formula derivations, again, many of us are stick to the concept written in a particular book or particular form. You have explained in the classroom. How far we are doing that justice with the student? So in the assessment, that formation of questions is very important, be it formative learning or formative assessment or summative assessment. I think it's my humble request to Association of Chemistry Teachers that there is a huge requirement of competency-based question in chemistry, and that too connecting with the real life. I think if you all can come up with this agenda, I think chemistry will be a joyful subject like any other language or any other humanities subjects. Under compulsions, many of us are choosing PCM, PCB combinations at senior secondary level. But if you ask a joyful choice, it could be different subjects. So that means there is a requirement of stress on chemistry teaching at elementary level, chemistry teaching at secondary level. That means 6 to 10, that chemistry teachings need to be revived. You need to relook and redesign your curriculum delivery. It may be you can connect with the gaming pedagogy, or maybe now we are discussing on toy pedagogy. So what way you are going to deliver the subjects, that depends on the teachers. And of course, the student and parents, their holistic connections is also very much important. So my request to all the teachers is that now it is time to formulate a new strategy for teaching. Rather, I should refer for learning, because this pandemic has given us an opportunity to look into the blended mode of learning. Somebody are also, this as a topic, it is also under discussion, that flipped learning. So all those things, during this lockdown periods, I was also compelled to look into the varieties of things worldwide, the practices by different international board, by different international university. And especially my search was with reference to the practical activity, because science, all science related subjects having a strong practical component, and how that international agencies are catering that requirement. So this is a real struggle we are facing in India. Of course, the alternative academic calendar proposed by NCERT was quite effective. But for the purpose of assessment and examinations, it is also not complete, because students need direct interface through which they can really connect with each and every experiment. So one way we try to integrate OLAB, which was already there in this our domain. So through OLAB popularizations, some schools definitely completed different kind of assessment, but due to connectivity and other issues, some schools also face problem, and till date they are facing the problem. Then we try to come up with another agency called ThinkTech from Bangalore, especially for secondary level, different kind of activities, which can be carried out at home without any physical interventions of teachers. But of course, if teachers are connected, then definitely they can, their concept would be more clearer. So again, all those activity we have uploaded in the Diksha domain. Now certain individual schools on their efforts, they have already carried out certain experiment in their physical lab, and that videographs we are trying to upload again in Diksha. So my request to association is that, can we institutionalize this kind of activities so that starting from class 6 to class 12, all the experiment, all the competency which aimed to be achieved by each and every student without any physical interventions, how these things can be videographed and given, and certain activities which individual student through do-it-yourself mechanisms can perform, then only we can promote the project-based learning at home and beyond COVID-19. This would be part and parcels of your blended learning approach. And teacher here need to become as a supporter, because there are a lot of online materials. But which one is to choose? If we put a simple Google search, there's so many things are coming in within a fraction of millisecond. But which are relevant for me? I am confused. So that relevancy indicator, I think the great teachers, great professors who are working day and night for chemistry popularizations, I think here is the time to understand the individual children requirement, his or her style of learning, unless it's until, and then categorizing. So you can divide your classroom into multiple parts, number one. Number two, the peer assessment or peers delivery of concept through this kind of Mentometer or some other localized mechanisms, I think it is highly possible to do without even any kind of technological interventions, even through WhatsApp also. Of course, again, I'm referring a technology, but without that also it is possible. So all those know-how, all those deliverable things need to be brainstormed. And for Indian context, for Indian schools, be it rural, be it urban, be it sophisticated or typical government schools, whatever, children are children. They have an equal capability in different area. So we need to identify them and put them that kind of capsule module which is easily accessible, so that ultimate aim is to make the chemistry a joyful subject. The third and last component here is how that multidisciplinary approach we can integrate with the chemistry teaching. And here my request would be how physics is connected, how language is connected. So in the month of March, I was searching to different websites. And here I like to, besides your IUPA websites and others, the Royal Society of Chemistry has a huge materials and different kind of pedagogy, different kind of online experimentations. So each and every materials are there. How we can bring all those material and make a strong use case in Indian subcontinent, that is need to be focused upon by the associations. During my visit to the Singapore, different Singaporean schools, as well as NIE, the teachers training component, they have rather invested a huge energy there. In teachers training component, the practical teaching through videograph and real-time capturing of the student performance is again a praiseworthy steps taken by NIE Singapore. So my request, all those literatures are very much available. Most of the literatures are available in the web domain. Now, some of you take a core group and identify which are usable here in Indian schools, and then create a roadmap. And from the side of Central Board of Secondary Educations, we are open. We want all the senior professors, all the school teachers, college teachers, please visit CBSE schools. And through these associations, already school teachers and college teachers and university teachers are connected. But how far these connections are visible in terms of curriculum design from school to university, and especially for the subject of chemistry, I think there are different disjoint I am personally want to highlight, because that's why that connectivity is also again important beside the classroom connectivity. So why I am going to learn chemistry? What are the potential career options, business options? How many teacher as a chemistry teacher, you are doing that, you are going to take this responsibility. It is not all alone responsibility of a career counselor or school counselor or principal. That connectivity, interdisciplinary approach, here everything. So chemistry, if has chosen as a subject or learning at elementary level and aiming to become a chemist at future, what are the different opportunity? As a teacher, you are supposed to explore, and whenever you are getting opportunity to take the class, within your 45 minutes, maybe your weekly 3-hour schedules, spend 5 minutes to discuss about the career options. Then only they will incline to take. Otherwise, unlike other subjects, the dropout ratios post senior secondary is huge. My last agenda, of course, I think I'm having 5-6 more minutes. Dr. Brijesh?
Yeah, sir. Yeah, you can please. Yeah.
Oh, okay.
Go ahead, sir.
So the girls and female participations in science subject, and especially on STEM. So across the globe, let us compare and also compare the Indian participations. So whether it is a problem of mindset, whether it is a problem of understanding, or whether it is a problem of lack of opportunity, I don't have a direct answer. I want answer from your side, so that girls' participations, female participations in research and innovations, which primarily they are more sincere, and I think that collective wisdom need to be there, so that I am not at all with respect to that gender bias, but at the same time, it is high time for girls' participation in more and more in science subjects. Of course, balancing would be all right, but there, how teacher is playing an active role in the classroom, that is also important. Otherwise, we male teachers sometimes with a old thought process, sometimes we are also playing a bias role. My humble request to all of you that we may forego all those things and let us bring all of them on the same plane, so that the Indian research culture, innovation in Global Innovation Index, our participations. Of course, we need help from all the foreign universities, all peoples who are already connected with you. We are already fortunate, but let us encash it. And especially for STEM area, we have different kind of club activities. in school, and especially for ACWA, Socially Empowered Work and Action, we are categorizing in class 11 and 12. So they are all kind of SDG related and chemistry related projects can be carried out right at class 11. And how chemistry is important in life, let us have a capsule module for the school goer, and especially for the humanity student, for the commerce student. Those things are missing. And nowadays, in this asynchronous mode of learning, I think everything is possible. Only thing is that to put the energy together. The last one is related to this curriculum in terms of in COVID periods and of course beyond COVID periods. I think again we need to relook and let us not keep ourselves stringent or rigid with the prescribed curriculum. Rather, let us focus on the learning outcomes, and different kind of pedagogy would be applicable for different students. So that personalized learning, and special request to all of you, the student with special need, they also need different kind of interventions. Otherwise, their inclinations towards science subjects will be a finite number always. We want whole soul participation because they might have huge potential for the research, but we are categorically stopping them to choose science subject at class 9 by means of their special ability or disability, whatever you call. So that kind of stereotype of thinking, we have to come out from them. And the last, of course, my last bowl ke bhi, I am putting a lot of things. So another request is, especially for science educations, many a time, and this is for the school leader, this is for the university systems. One way NEP talks about multidisciplinary learning. So my questions to all the senior professor, whether I am eligible to pursue a career on chemistry without taking physics at my 10+2, without taking maths at my 10+2. So we need a clear-cut answer for the parents. Otherwise, multidisciplinary approach of learning would be only on policy document, not on reality. So my humble request that connections need to be established at the earliest. And what a BSc first year students need to do while joining a first year BSc chemistry honors or plain BSc honors or BE chemical engineering or pharmacy or MBBS. So those outcomes are not clear-cut defined. Everything's are equally important. So we are treating generic breed. So that should not be the systems of curriculum design. So my humble request, as per the, if certain student dropouts from 10+2 and opted chemistry as a subject, what kind of entrepreneurial activities are open for him or her? What kind of job opportunity is there? Those questions are till date unanswered. So for STEM education, I think more energy we need to put together so that each and every individuals like to enjoy their school days, not like a confused citizen, whatever portrayed in Three Idiot and other regional film. So one way it is reality. Let me openly admit this is a reality. So from that confused culture to competency culture, it will require a time. So my humble request to all the member of SCT, let us brainstorm. Let us come up with a strategy and roadmap. So by the end of May 2021, we are going to do this. So let us take a 3 years plan, especially for the chemistry, and see the outcomes. And my sincere thanks to all the eminent dignitaries from abroad who have joined us in this NCCT 2020. And of course, compliment to organizer for inviting me. Thank you very much. If there is any questions, I think let us break the one side audio video. So let us take some questions. Thank you. Namaskar.
Hello.
Thank you, Dr. Biswajit, for very informative lecture. I think
Really?
many have some questions.
I have a question.
Yeah, there must be. Yeah, please.
I'm Dr. D.B. Prabhu, Secretary of Association of Chemistry Teachers. Professor Biswajit Jha, you have given a wonderful lecture. And what I liked about the lecture most is that the outcome is very important. How much the student has learned is rather more important than what we have been teaching. And I think in our education system, this is what we have to emphasize, that how much the student has learned should be considered as more important. And as a organization of chemistry teachers, right from schools, colleges, universities, and even scientific institutions, we would be interested in making audiovisual presentations of experiments at school level and college level. Already some of us are having an experience of making films on experiments. So I would like to request you that can we collaborate in this project of making audiovisual presentations, PPTs about experiments. Thank you.
We are open because the country need huge repository, and as I have mentioned that personalized learning, for that there are a lot of repositories required. So we are open. Please write to us, and I think not only audiovisual and presentations. Besides this, let us also create a quality question bank, because all those, if we analyze our last 15-20 years questions of chemistry at senior secondary level, at secondary level, at senior secondary level, definitely certain competency mapping has already been created. But at secondary level, more direct questions and more on science history. So secondary level, so that science history, even let me tell you, our social studies curriculum, the history of so many empire and other things, I think the science history maybe we can put there.
Yeah.
And here, in case of chemistry and physics, biology, the more focus should be there on competency teaching and new areas of science innovation. Not because science history, they can this could be accommodated as a portion of history itself. So besides your political history, we need to also know the science history of ancient India, and so that connecting with the root is also very much important. Thank
Sir,
you.
1 minute also, what Professor Prabhu has told, I want to substantiate, like Association of Chemistry Teachers has been into the teachers training program. Always we have been doing it at our level. So what the Professor Prabhu has requested you, I too request you that we can collaborate with CBSE. I mean, the SCT can collaborate with CBSE for teaching science teachers of secondary level. I mean, just a kind of an orientation programs, a continuous program we can have it, So we can send a proposal for that. And,
why not? Why not? Yes. Thank you.
Okay. Thank you, sir.
Thank you.
Any more?
No, thank you, Sudhaji.
I would like to add something. Actually, what you have said, that designing curriculum and chemistry teaching revision, the prime motto of ACT when it was established, this was the prime motto for curriculum designing as per the requirement. And this is what you have very clearly mentioned. We have to make a strong base. So that is the class 6 to 10 to motivate the students to opt for science subject, basic science. It is not only the chemistry. We have all seen the decline in the science subjects. So class 6 to 10 is really very important to motivate them. And no doubt, this pandemic has taught us for this online classes, audio and video. Before that, I think we were not very much inclined towards these video experimentation and this. And we all are facing a big problem for experimental section, because the theoretical part we can take via online, it is very easy. But for experiment, it is real difficult task. So it's a real very good session and very good lecture. ACT has shaken hands. I think it's okay. So ACT will shake hands with the CBSE.
Yes, yes, sure.
Okay.
You're very
So,
open.
very
you,
good.
Thank you,
It's a
sir.
good achievement
Thank you,
Yeah.
yes.
for this lecture. We have achieved a lot. ACT has achieved a lot. Thank you, Professor Vishwajit Saab, for this.
Vishwajit sir, we have a question from our participant, from Jaya ji. She is asking about, please wait for, yeah. She is asking that how CBSE is planning to change assessment so that it reflects the learning of outcome rather than content based on NEP.
Yeah. So already, let me answer that question. So already we have initiated, and if we look into our last year class 10th question paper, so there already 10% questions is related to competency based. And then this year we thought of implementing case-based questions also. But due to pandemics, already there is a huge loss of huge academic loss, and to maintain a uniformity, maybe certain urban schools has carried out good conducted classes, but at the same time some rural school and even some schools from urban area also suffered a lot. Still they suffering due to all those decisions taken by different government and different school management. So this year, case-based questions we are not introducing, but maybe from the subsequent year, this would be a reality. And by the times we reach to 2025, at least 50% questions would be competency-based. And that the roadmap we are going to discuss with you all. And that's why we need a huge bank of questions. So we need your support. And that does all strategy already we have adopted. It's only the COVID and post-COVID time when CBSE is going to officially declare all this strategy. Thank you.
Any other question? No? So once again, thank you, Dr. Vishwajit Saab, for commendable lecture. Thank you very much.
Thank you, ma'am.
Thank you, sir.
Thank you, everybody. Namaskar.
Thank you, sir.
Now we move to next speaker. He is Dr. P. Sivaswarup. He is specialized in physical chemistry from Andhra University. And he did his PDF with Professor Desi Raju. He is an elected fellow of Royal Society of Chemistry and life member of American Chemical Society. Has published a number of papers in national and international journals of repute on multiple dimensions like chemistry, ethics, and distance education. Dr. Sivaswarup is presently working as Regional Director in Indira Gandhi National Open University, IGNOU, the premier distance education institute in the country. His focused efforts on reaching the unreached sections of the society in Vidarbha and providing educational opportunity to them is yielding results. Starting from tribal youth and women in interior villages of Gadchiroli, which is an aspirational district under left-wing extremism identified by Honorable Prime Minister. Prisoners in Nagpur and Amravati central prisons, commercial sex workers, transgenders, slum dwellers, etc. They have restarted their education through IGNOU Nagpur Regional Center. Dr. Sivaswarup has paid special attention in spreading science education through distance mode. Many people who studied science up to 12th standard and could not continue further studies, they joined employment for their sustenance, are brought back to pursue their unfulfilled dream of science graduation through IGNOU. As a result, the cumulative BSc enrollment in the region is around 3,600. Dr. Sivaswarup is an active member of RSC West India chapter and organizes various outreach activities, especially for interior tribal students. Experts from premier institutes like TIFR, IIT Mumbai, NCL Pune addressed and interacted with students of Gadchiroli, Gondia, Yavantmal, and Nagpur districts. For his dedicated efforts, Dr. Sivaswarup is conferred with various awards like Vidya Bhushan, Shiksha Marsh, Seva Ratna, Best Services Regional Center Gold Medal, etc. So with this brief, I request Professor Dr. P. Sivaswarup for his presentation. Dr. Sivaswarup, please.
Thank you, Professor Jain, for nice introduction about me. Thank you so much. And at the outset, good afternoon to Dr. Prijesh Pare, Dr. Damodar Prabhu, and all the ACT members, and also all the participants of this very lively sessions which are going on. And let me share some of my ideas on this topic, technology-driven education in 21st century. And we have seen yesterday the Angela Wilson, she said about shrinking world, increased globalization, and easier communication. And these will be the driving force for even education also. And after listening to the Professor Peter Mahaffey and Dr. Biswajit Saha's lectures, let me share some of my ideas on this topic. Of course, Mahatma Gandhi is relevant even today. This quotation, what he gave at the beginning of the 20th century, is very much valid even in the beginning of the 21st century. He said, a teacher who establishes rapport with the taught becomes one with them, learns more from them than he teaches them. And in this way, a true teacher regards himself as a student of his students. If you will teach your pupils with this attitude, you will benefit much from them. This is more useful in today's time where our students are more knowledgeable in using the ICT techniques. As a teacher, we may be knowledgeable in subject, but they are more knowledgeable in the ICT techniques. So we should join them as a learner. That is what Dr. Biswajit Saha has said. We have to become a facilitator. With the information explosion, it has become very difficult for students to search also. There, the teacher becomes a guide and facilitator for them. At the outset, I have two basic presumptions. One is, sincere and committed teacher is unique and he or she has no substitute. That is the first concept we have to understand. And second one is, technology is only a tool. It is only a tool for providing varied learning experiences, but not a substitute for a best teacher. So after keeping these two in mind, we will proceed. And my topic I will cover in various aspects, that is technology dependent education growth, then teacher and classroom transformation, how we have to change from 20th century to 21st century, and what are the new trends coming in, and National Education Policy 2020 will be there and it will decide the future of the education in the country and how we dealt with the technology, and some of the techniques like MOOCs, blended learning, flipped learning, digital learning, and at the end, I will give some resources, e-resources for chemistry. So coming to the point of technology dependent education growth, and we can see education system is dynamic and vibrant with the society. It responds to the societal needs by assimilating the new technologies. Whenever the technology comes in, like today we are discussing the technology driven education in the 21st century. And it is not a new concept, it is a age-old concept which education system has been assimilating the new technologies, and a new mode of education has evolved. And purpose of this assimilation is to reach to maximum people and to give an organic approach than a mechanical supply of knowledge. This is most important. We have to give a organic approach by using these technologies. That is most important. Let me share with you a spiral model where it says technology-based growth of education system, ABCD model. It is a spring model where on left side you can see technology and right side you can see the mode. In primitive times, there is a primitive technology and it is ancient mode where we have the Talapatra Granthas, where the books are written on Talapatra Granthas. It is a handwritten. It is a primitive technology. And next, when printing machine was invented by Gutenberg, the textbooks were printed and it started blackboard, that is classroom and colleges and schools they have started. Till before that, it was only Gurukul Pathshalas where the students were going to the teachers who are residing in the forest, isolated places for a better education purpose. After that, when transport system was invented, correspondence education has started where the textbooks were sent to the learners' houses through transport. Next comes when audio video technology has come in, it has led to distance mode of education. After that, when information communication technology has come in, we have entered a e-learning facility, that means the electronic mode of education. Next comes the flexi learning, where students are given flexibility of they can do education through regular colleges or through universities or through distance mode, and they can do first year course from one university, second year from another university. They can have a flexi mode of accumulating grades, and even in the national education policy, they propose credits for the cultural activities, vocational activities also. They also will be considered for the award of the degree. Total credits to be accumulated. So in this mode, we can see that the technology has been assimilated by the education system, and step by step it is growing and reaching out to more and more people. So we can see there are 4 types of learning. One is formal learning, which deals with all the colleges, schools, universities and others. There is informal learning also, and self-learning and distance learning. Different types of learning we come across. Coming to the classroom transformation from 20th century to 21st century, we can see the 20th century classroom is a teacher-centered. Teacher is the center of attention and is the provider of information. Teacher was the only source of information for the student. Whereas in 21st century, it is a student-centered and teacher is a facilitator, because student can access multiple sources of knowledge from any source, and he will acquire the knowledge, and teacher has to facilitate in understanding them or guiding them to what are the sources they have to go through. And in 20th century, student working in a relatively isolation and classroom and memorizing facts, because in classroom we maintain strict discipline, no noise, strict silence. So there is a isolation which was there. Whereas in 21st century, student will work in real life collaborative learning. So the last century it was textbook based learning. Now it is research based, because contents comes from the search of various resources. It was a passive learning earlier. Now it will be active learning. All these are for a normal teacher. A committed teacher will make a active learning even in a classroom also. Okay. and little or no student freedom in the earlier classroom situation, whereas it is a great deal of student freedom. And teacher is the judge. No one else sees the student work in the earlier system, whereas it is a student work is seen self by peer or any outsider can watch the whatever the work done. The diversity in student is ignored because of the heavy workload. The diversities in students, they cannot be attended much, whereas in today the curriculum and instruction, they address the variety in the students. It was earlier formal, now it is informal in future, and it was time dependent, whereas now it will be time independent syllabus. Whereas in earlier system, not all students were fully participating. Front benches, mid has to be. But here, all students, they have to participate actively. Then only they can complete the activities. Here, in the last century, teacher is more responsible for the learning process because teacher is responsible for the student passing and other things. Whereas in next century, coming century, the learning process is this learner is responsible for his studies. And the thing is, the teacher transformation. Even though the teaching was perfect, we have the best teachers among us, and that's why we got our students occupying higher positions across the globe. But still, the needs and requirements of learners, they are changing. In the 21st century, the students, they are changing, their requirements are changing. So teacher transformation is also required. It doesn't mean that our system was wrong, it was good, but still, as per the learner-centric education, we have to change. In 20th century, the teacher was like a sage on the stage because they maintain a strict discipline and pin drop silence. I remember when we studied +2, our mathematics lecturer, he was combining both Telugu and English medium students together, 200 students. Even then, there was a strict pin drop silence in the classroom. No one should ask a question, no one should even sneeze also. He was so strict. So it was like sage on the stage. When a guru speaks, no one will question. Of course, it was old days gurus. Nowadays, we see so many babas, gurus, and religious leaders on TV channels. They come and they interact with us also. Whereas 21st century teacher should be like a guide on the side. It is on the left side, we can see this 20th century teacher was like always being viewed as the content expert and source of all answers. So teacher was supposed to answer all questions of the students. Whereas in 21st century, we should be participating at times as one who may not know at all, but we also want to learn. Then only we should be like that, guide on the side. And earlier it was teacher was viewed as the primary source of information which they feed to students. It was teacher was at a higher level, student was at a lower level. There was a flow of knowledge from the teacher to the learner. But now all are almost in the equal level. When we teach, they can search the Google and they can find further to our whatever we are teaching. So whereas in 21st century, the teacher should be like a viewed as a supporter, collaborator. And the teacher in the earlier classroom, they were asking the questions and controlling the focus of student learning. After every 10 minutes or 15 minutes, they used to ask on the topic covered. Whereas here, we have to coach the students and ask them to explore the answers. Earlier, directing students through preset step-by-step exercises so that all achieve similar results. Whereas now, we have to guide these two students to actively encourage them to pursue the knowledge and by guiding them. So the key to 21st century classroom is, it is the teacher who has the power to guide purposeful learning by the students. Even today, with multiple sources of knowledge, it is the teacher who will guide the student. And the power of teacher comes not from the information he or she shares. There may be multiple sources, but from the opportunities he or she creates for students to learn how to learn. A teacher has to create a learning atmosphere in the classroom. That is most important. So how to learn? how to solve problems, etc. That is the most important. There comes the teacher's role. So proper integration of technology rather than simple use of technology or acquiring technology makes no sense. So we have to integrate them into the classroom. So we can see the 19th century and 20th century classrooms. Left side, we can see how attentive the students are listening. Right side, we use the OHP and other things where we have interactive sessions. Now, post-COVID, the 21st century classroom is like this. The teacher teaches without students, and students, they learn at their homes. So there is no teacher, there is no contagious contact between teacher and it is always a mediated communication between teacher and the taught. We can see how the classroom will change. With this ICT technology, we can see there are more mobiles than graduates. We have 93% Indians have mobile or landline connection. And then there is only a 6% graduates in India. This shows where the teacher's role is more and more, and how we can use the ICT and mobile-based technology for reaching out to the students and increasing the higher education. There are several points. Future of education, we can see we need to be globally minded, because future students, even the national education policy says about to create students who can fit into the 21st century skills. So like this, there are so many skills we have to go in, and let us see some of the major trends in education technology led learning for 21st century. And this technology has made collaborative learning very easy. By sitting in Nagpur, I am able to talk to so many people across the globe. Morning we listened the expert from abroad, maybe Canada, and yesterday we listened from US, like this. So the technology has brought in the possibility of collaborative learning, and it was earlier restricted to only few people. Now it is available to anyone. So, and we connect, discuss, and enact upon situations collaboratively. This collaborative approach has gained importance in the learning process also. And another advantage is the teachers are far more accessible now and act as mentors for the students throughout the overall development. Today, we organize Zoom meetings or Google Meets even at night at 8 o'clock, because we know that they may be busy in other meetings, and we organize meetings at 8 o'clock in the night also, which was not possible earlier. So this collaborative learning has broadened the concept of the classroom and knowledge sharing. And next thing is learning outside the classroom environment. Earlier, students used to feel the teaching happens only in the classroom, but now it has changed. Mobile-based books, devices have taken learning outside of the classroom. A student can learn anywhere, anytime. It is a anywhere, anytime concept. They can learn and they can acquire knowledge. Even the e-books, they have embedded many features, and they are also can be used by anyone, anytime. And the next one is the social media in learning. We never thought that social media would one day be accepted as a part of the learning process. Teachers used to stop why you are watching Facebook in the classroom, but now it is accepted as a learning tool. There are many universities, even in our own university, when we made a survey, because during COVID-19 pandemic lockdown period, students were at their own homes, and we made a survey which were accessible to you. Majority of them said Facebook is more accessible for them. So we conducted classes through Facebook. So social media has become a learning tool today, and teachers also use several social media, and WhatsApp is an excellent tool where to communicate, to send the videos, to send the questionnaires, and so many things. Even Telegram groups, they allow so many communications with the students. And next is interactivity in classroom. Bringing technology into the classroom has made classrooms lively and interactive. So there is more interaction between teachers can now assist and guide students with their homework across. My daughter sends her teacher a message night at 10 o'clock while working on an assignment, and I am happy the teacher also responds immediately through WhatsApp. So this interactivity has brought in, and the next one is data management and analytics. Earlier, the teacher's activity was more in valuation and other things, student performance, how they are working and all these things. Now, with this automation in the classroom activities, at a click of a button, a teacher will know which student is doing better and what are the better performances. Subject-wise, question-wise performance is also reviewed. And immersive learning with augmented reality and virtual reality. We all know that the augmented reality provides an enhanced view of a real image, and virtual reality gives a false perception of reality around them. And for example, a virtual reality kit allows biology students to go inside the human body and see the inside how it works, how its body works, like this. So it improves the understanding capacity of the students. Gamification. Now, the games have come into the classroom, and because it will make students to involve themselves into the subject and learn better, and to make them more effective, incorporating game-like elements can be simple as replacing some grades with learning badges. You all know that those who are knowing about the video games, there are badges and others. We can have it. At the end of my session, I will give you some examples of the games in the chemistry also. I was watching one game. They say for all the organic structures, they make as a gym, organic gym. In that, the molecules, the atoms, they bend themselves, they do stretch, all these exercises, and they teach the students about how they affect the structure, like that. And next thing is, when we go for the online activity, the online data and cyber security are most important. Otherwise, now we are more prone for cyber attacks. So we should be take care about this thing. And we also have to address about the cyber bullying. In a classroom, there will be bullying, and there will be cyber bullying also happens in the classrooms. And artificial intelligence, that also makes a sense in the classroom, where there is a package where it sees the facial feelings of the student, and it automatically adjusts the lesson as whether it will follow, it will catch whether the student is understanding properly or not. Then automatically it changes the level of the subject. Artificial learning is also happening. Now coming to the National Education Policy 2020 and how it has envisaged technology into it, we can see technology use and integration. We know that India is a global leader in ICT, and some of our Indians are heading the major global companies, IT companies, and also the Digital India campaign is helping transform the entire nation into a empowered society. And here, while education will play a critical role in this transformation, technology is important to improve the educational process. Here it is a mutual. Our people are heading the IT companies, and also we are having the Digital India campaign. So in this way, we have to use technology also for reaching out. So the NEP has suggested National Educational Technology Forum, NETF. It will be provide a platform for the free exchange of ideas and use of technology to enhance assessment, planning, administration, etc. and it will facilitate decision making and the induction, deployment, etc., and use of technology. So the equitable use of technology is more important because we all know that there is a digital divide in the country. And so to circumvent this difficulty, there should be more Digital India campaigns. And we also cannot expect a good teacher in a traditional classroom will automatically become a good teacher in an online classroom. So there should be a teacher training concept also included in this NEP. And this policy recommends following key initiatives like there will be pilot studies for online education, like appropriate agencies like NCERT, NIOS, IGNOU, IITs, NITs. They will be identified to conduct a series of pilot studies and to evaluate the benefits of integrating education with technology. And digital infrastructure has to be developed, and also to provide online teaching platforms and tools like Swayam, Diksha and others, so many things. And next, addressing the digital divide, they want to use the existing mass media like television, radio, community radio, all these things, they will be used for educational broadcast. Gyan Darshan is also a TV channel, Gyanvani, they are radio channels, and the Gyan Bharati, they are the TV channels. Now coming to the MOOCs, some of the activities like massive open online courses. Nowadays, many people know about it. The MOOCs is a sort of digital learning platform where courses are open and majority are offered free of cost. And for MOOCs, all we need is a PC, internet access, and some basic computer skills. It was originally coined in 2008, and even 2012 was named as the year of MOOCs, and in 2018 it was year of MOOC-based degrees they mentioned. And the increase in MOOC learners is also increasing. In 2015 it was 35 million, and in 2019 it has become 110 million. Even in 20, it has manifold increase in this number of learners because of the COVID-19. So those data has to come out, and the major trends are the MOOCs is moving from free module to payment mode, and they are also offering degree-based courses. And there is a fear that whether MOOCs will replace the traditional universities. There are several courses in MOOCs also, you can go through them. And there is a fear that whether MOOCs will replace the universities. So there is a concept that at the beginning of the MOOCs, people felt it may lead to demise of the traditional universities. And there are protests by teachers against the expected disempowerment of educators because of MOOCs. But the excitement has subsided. As I said, there is no substitute for a classroom teacher. MOOCs are viewed as an additional technological tool of modern education only. And so the Swayam portal, you all know, Swayam platform is a part of Digital India initiative to empower the nation and citizens through technology, and with several courses from different subjects. Swayam is one of the world's largest MOOC provider. And now the specialty of Swayam is integration into India's education system, integrating online and traditional education. Even UGC allows the regular college university students to complete 20% of courses through Swayam. And with thousands and thousands of courses on MOOCs, how to select a course? First, you have to decide what is your objective to join a MOOCs course. Whether to revise your existing knowledge, or to learn new knowledge or topics, or professional development. You have to decide what is your idea of joining a MOOCs course. And every course has an introductory video or summary. Please go through it closely. If it sounds useful, then continue. So watch the introductory video, and if you feel it comfortable and matching your objective, then you can join that course. Anyhow, these courses are free. So just sign up and see whether they are useful for you or not. And MOOCs are flexible. You can study the desired module only. No need to do entire course because they are free. Out of few lessons, you can go through the lessons which are suitable for you. Others, you can leave it. So next, coming to blended or hybrid learning, let us see. Blended learning or hybrid learning is a learning model that combines both formal and non-formal methodologies. It integrates technology to boost learning. What the UGC has given 20% courses through Swayam online portal is also a sort of blended or hybrid learning concept. Huge online content is available, and how best to use this content in teaching learning process, it led to blended learning. And due to this, the classroom is going online and the classroom conversation is becoming online conversation. So in this way, the teacher's toolkit has expanded enormously. So to deal with this, teachers should be multi-skilled. They have to know first how to guide the student. So they should go through all this. Then here we can see the concept of Ramakrishna Paramahamsa, and we all know that story when a mother brings a small child to Ramakrishna Paramahamsa saying that he is eating sweets so much, please advise him to stop it. He said, you come to me after 1 week. Then the mother was puzzled. Anyway, she came after 1 week. Then Ramakrishna Paramahamsa advised him, stop eating, it is not good. Then the mother asked, Swami, why you asked us to wait for 1 week? Then Ramakrishna Paramahamsa said, before telling the person, I should stop it. Similarly, an ideal teacher follows what is telling to others. Similarly, here the teacher has to be multi-skilled. They should taste all these online teaching and other things. Then only they can suggest to the student where to go and what to use. The curriculum design is more crucial to meaningfully incorporate the learning technologies to enhance learning in and out of classroom. So here, curriculum design, that's why we should have instructional designers also as part of the curriculum design team. Then only we can effectively integrate technology into the classroom teaching. So for success of this system, the stakeholders like students, teachers, and others should know the objectives of blended learning, when to use online and when to use offline. We have to be aware of all these things. In a faculty survey in USA, 9 out of 10 said that they are using fully online or blended format. Whereas after COVID, majority have become online teachers only. It allows greater flexibility to learners. They are constantly connected to the content, and it increases user engagement, and it gives analysis of learner activities and their performance, because many of these online portals, they give immediate response, immediately analyze the students, how far they understood, how many lessons they studied, all these things. So in Penn State University, they selected a chemistry course which has both high failure rate and low student retention rate, and redesigned it to blended format with the help of experts. And they found that it increased average GPA and pass percentage also. Coming to another form of blended learning, inverted or flipped learning. So it is like Walden inversion. Here it is a totally inverted system, whereas we have seen traditional classroom teaching is 100% classroom teaching. In blended learning, it is part majority classroom teaching and part only online online teaching. Here it is like a Walden inversion. It will be majority will be online class and minimum will be classroom learning. So here it is just like doing schoolwork at home and homework in class. It is a inverted learning. Here the learning material is given to the students and they come to the class to clarify their doubts and to get understanding of the topics. So it is applied to various courses. But the common principle is students independently acquire the course knowledge remotely and using classroom time for more interaction. Here, the teacher is free from teaching the conventional subject, whereas the students have read already, so they will come to class for more interaction to attend to the individual student queries also. It is more possible. Coming to the next stage of distance or digital learning. Distance learning is the form of education in which there is physical distance between teacher and taught, unlike in a conventional teaching where teacher and taught are within the same classroom. And digital learning includes any learning experience which makes use of technology in its diversity and facilitation. So there should be a scope for student interaction rather than simply sharing of ebooks, etc. Due to increasing social demand, social advances and technological advances, distance education has emerged. In our society, if we see, earning is more important for many people. So they prefer earning. Our social conditions make them like married women, they cannot attend regular colleges, so they prefer distance education. So coming to the next point where I will share with you some of the e-resources available in chemistry. They are like, this is very meaningful picture. There are so many e-resources in chemistry. You can see the picture. It doesn't matter how many resources you have. If you don't know how to use them, it will be never be enough. You can see this person has to see other side of the wall. He is using all the ladders like this. Even a single ladder kept straight would have been vertically could have been useful for him, but he used all the resources horizontally and trying that still it is not sufficient. So we have to know first what is the use of the e-resource and how to use it. Then we can properly guide the students. E-resources in chemistry, this is compiled by Dr. Gomti Sridhar from VKKM College, Mumbai. And in a presentation, she made this. And there are several sources for lab equipment, lab experiments. And there are so many virtual labs where students, you can play them. And there are reaction mechanisms, chemcube3d.com. And you can show the students these things. And 2D chemical structure drawing software, and then online video and web interactive lectures, and periodic table also. You can hear the elements they speak like this, and visualizers, orbital viewer, and ChemSketch 12, all these things, because to visualize p orbital, d orbital, and all these, it will be more useful using these visualizers. And games through chemistry, you can use them. As I said, the stress and strain in the chemical bonding, you can explain through this. As I said, there is a molecular gym where the molecules will weigh and they will show the stress where they get and how they relax, all these things. So stereochemistry, you can explain through that. Online video and web interactive lectures. And these are several e-resources for self-learning compiled by Professor Sanjeev Kumar from IGNOU New Delhi, and Sakshat e-portal, Swayamprabha, and CEC, Swayam, e-PG Pathshala, e-Gyankosh. e-Gyankosh is a digital depository of all online material of IGNOU, study material for all subjects, video and audio lectures, they all are there, and anyone can access it. They are free. All these are free. Open Textbook Library, National Digital Library is also a very useful resource, and OER Commons, e-Acharya, Virtual Labs, NPTEL, all these are freely available. And the e-resources we have are eGyankosh, web-enabled academic support, FB Live, and YouTube All these are freely available. Anyone can watch our FB live sessions. They are available on IGNOU website. And other national e-resources are Swayamprabha. Channel 8 is especially for IGNOU and CEC, UGC, and all these things. You can go. There are global e-resources also. As I said, there are so many resources available, and you have to test it first so that you can guide the students. And at the end, thank you for patient listening. And here I stop. Thank you very much. And if there are any questions, we can have it. Thank you very much.
Thank you, Dr. Sivasaru, for the very, very informative lecture and emphasizing technological driven education in 21st century. Very well said. ABCDF model. You have very well explained just by taking ABCDF. Everyone can even remember. This is the way how a very good teacher just made simplify the complex subject. This is a very good example you have taken. Yes, you have addressed about that Zoom meeting webinar, and really we also agree upon this, because we find this webinar, they are really wonderful, very informative. We may have very good speakers we have because of these webinars. And what you have told us is about MOOC courses. The best thing which you have told us, you have emphasized about how to select the MOOC course, because no doubt there are so many available and the students, they are not able to select. So you have guided how to select the MOOC course. And yeah, this technology, no doubt, has enormously increased the teacher's tool. Now the classroom lectures, they are different than the previous ones. And one you have mentioned about gamification. So I would like to add here, from the first lecture we started, that Professor Mahafi, that was like a game, nothing else. He asked us to go on our smartphone to that link and just answer it. So the first lecture also started with the interactive session, like how we can start an interactive lecture. And the last lecture also, it was very interactive. Again, you have mentioned about gamification. And you have provided so many information about the websites available where one can get either the experimental part or these lecture part. Everything is available. So we would like to have these links. Many have asked about the links because no one was able to write it. So sir, we would like to have the links. And
I'll send through email to you. You can share it.
Okay, that's very good. Thank you very much, sir. And time is very less. We are behind time. So I think if anyone has question, he or she may ask one question. We may, Professor Premmohan Mishra ji, can we have one question? So one question we may have, if anyone has. No questions. So the lecture was no doubt very clear. And nowadays it is the pandemic which has taken us to online courses. But IGNOU has started these courses long back. So who is asking? No. So thank you very much, sir. I once again thank all the three speakers for today's session. All have given wonderful, very informative lectures. Thank you very much.
Thank you so much. Thank you for all the patience. Thank you.
Now, over to Dr. Nayan, please. Dr. Nayan, please unmute yourself. Dr. Nayan?
Yeah, he's right there. Sir, unmute. Yeah, you have to unmute. Acha, Sunny. Hello, Sunny. Unmute Nayan Kamal Bhattacharya. Dear Sunny.
Bhattacharya sir, you can unmute yourself.
You can unmute here.
Thank you, Sudha ma'am. Now, our first session is over. We have the technical presentation. Mr. Sir, can we have 5-10 minutes break or should we continue? Sir, please unmute. Sir, please unmute, sir.
No break, please. We are running short of time.
We are running out of time. Yeah.
Yeah, so we shall start presentation. And 2:30 at sharp, we have to stop it and start lecture of Professor Javier Garcia Martinez. So we shall try to take up maximum presentation, but if someone left, I will take it after 4:45. No problem.
Yes, that's good.
So we should start. Mr. Shaniji, please unmute. Professor Shraddha Sinha ma'am, Dr. Umesh Chandra Jain, and Dr. Manan Krishnamurthy. They are the judges for this presentation. Shraddha Sinha ma'am, Umesh ji, Dr. Umesh Chandra Jain, and Dr. Krishnamurthy, Manan ji. Are you there? Shani ji, you are being.
Sir, I have unmuted. I have provided course rights to Umesh Chandra Jain.
Yeah.
I can't find Shraddha ma'am.
Okay.
Ma'am, if you are available in the meeting, please raise your hand or tell me, write in the chat option.
And Sunny, yeah, unmute Krishnamurthy also. Krishnamurthy.
Krishnamurthy.
You have to unmute him also, yeah. Krishnamurthy.
Yes, sir.
Mahesh ji, you are ready?
Yes, sir. Good
No,
afternoon.
have you unmuted Krishnamurthy?
Yes, sir. I have unmuted Krishnamurthy.
Krishnamurthy, you can do it now, yeah, okay. You can unmute yourself now.
Yeah. Can you listen?
Yeah.
Yes,
Audible.
sir. You are right.
Okay, sir. So we should start.
Yes,
I have to take one name from yesterday's presentation, Dr. Amar Srivastav. Because yesterday he was in a panel of judges. So I will present today. Amar Srivastav is ready for presentation?
अरे यहाँ से
Amar Srivastav ji, please. If he not present, we move forward. Mr. Venkat Raman. I am reading the names of presenter. If they are present, please raise your hands and get unmuted. Mr. Venkat Raman
Amar Srivastav is present.
Yeah. He will present.
Srivastav sir, please unmute yourself.
Ujma Parveen, Balveer Sharma, P. Radha Krishnan, D. Shravani, DVV Durgaveni, Kandarp Fukan, Manisha D. Patil, Manoj Kumar, Naveen Kumar, Om Prakash Meena, Rahul Mahurle, Ram Babu Parikh, Santosh P. Chakole, Syam Goswami, Sudipta Chutia, Sunita Singh, Garima Nagraj, Dr. Archana Singh, Dr. Shashi Bala, and Dr. Nisha Garg. This is the list.
Sir, can we do one thing? Hello.
Yeah.
Mishra sir,
Yeah.
I should do one thing. I will be removing the force mute condition, and
Yeah.
in that case, they can unmute themselves one by one.
Okay, no problem. Yes.
So participants, I am
Okay.
removing the force mute condition, but please keep this thing in mind. Don't unmute yourself at the same time. Not more than one participant should unmute themselves. If
Yeah.
one person has unmuted himself or herself, you should mute yourself.
Amarji is present. Amarji is present in the meeting.
Sir, Amar Srivastava is available in the meeting. He has unmuted. Sir, everyone will get muted. Amar sir, you can unmute yourself. Now you can unmute yourself, Amar sir.
My name is Gyanasri Bara. My name was also there. I received a mail, but right now in the list, my name is not present.
Mishra sir, please unmute yourself.
Mishra sir, you unmute and reply to this query. Yes.
Yeah, Gyanasri Bora will get chance.
Okay, thank you, sir.
Sir, I am
Amar sir,
Rambabu
please
Parikh.
unmute yourself.
Sir, I am Rambabu Parikh. I can present my paper now.
You have to wait for your turn, sir. Sorry, sir.
My name is also not there.
Hello.
Yeah.
Amar sir, please can you unmute yourself? Sir,
Venkat Raman is there. Venkat Raman.
Venkat Raman, sir, you can unmute yourself. Please unmute yourself.
Is not. Chandra Mohan Prasad is there. Going to present. Uzma Parveen. Uzma Parveen. No, not. Balveer Sharma. D. Radhakrishnan.
Yes, sir. I am present, sir.
Balveer Sharma.
Radhakrishna.
Sir, D. Radhakrishnan.
D. Radhakrishnan. Yes, start please.
Yes, sir. D. Radhakrishna.
Yeah.
Okay, sir. Sir, would you permit to share screen, sir?
Yeah, yeah. You are permitted. Start.
Now you can share your screen. Radhakrishnan.
Avoid experimental part and finish within time.
D. Radhakrishnan, please unmute. Please share your screen.
Yes, sir.
Yeah, your screen is shared.
Okay, sir.
D. Shravani remain present
Yes, sir.
and ready.
Sir, my name is D. Radhakrishna. I present poster presentation, sir. First one is spectrophotometric determination of nigrosin and aniline basin water samples after cloud point extraction using mixed mycelis, sir. Mixed mycelis means TBAB and TX114. The introduction and experimental procedures. Colored wastewater not only affects the aesthetic merit and water transparency of receiving water bodies, but there are also environmental concerns about the possible toxicity and carcinogenicity of some organic dyes. Then I choose cloud point extraction. Cloud point extraction means CB is based on the clouding phenomena of surfactants at a certain temperature called cloud point temperature. In the mixed mycelis cloud point extraction, a small amount of either cation or anionic surfactant has to be added along with anionic surfactant. The anionic surfactant in the mixed mycelis specialists and pair formation with the charged analytes and convert them into more hydrophobic species. Their hydrophobic species are then easily extracted into the mycelis of anionic surfactant. We are using materials. Materials are used Triton X114 means polyethylene glycol, tetraoctyl phenyl ether, and the TBAB and the other surfactant tetrabutyl ammonium bromide. These are mixed mycelis. to form mixed mycelium and nigrosin and the inland blue dyes sodium sulfate. Sodium sulfate is salt and the acetate buffer is pH. Next. We are using method. The extraction of nigrosin and inland blue from water samples is based on the measurement of absorbance of the dyes at its lambda maximum 574 nanometers after dissolving the surfactant rich phase in 20% methanol using UV visible spectrophotometer.
Avoid experimental, go to conclusion and results.
Yes, sir. I'm going to results and discussions, and we are using surfactant and concentration. Concentration is TX1 for 2.2% and salt is 2.4%, temperature 70 degrees Celsius. The equivalent time is 15 minutes and following graph are there. Next we are going to conclusion. We are using lambda maximum 574 nanometers, linear range is 0.02 to 7.936, LOD linear limits of detection 2.53, correlation coefficient 0.9985. Reconcentration factor is 10, phase volume ratio is 0.11, extraction efficiency 96%, and we recovery 92 to 101%. Thank you, sir. Thank you, sir.
Thank you. Thank you. Thank you, Radhakrishnan.
3,
Thank you.
5.
Amarji is ready to present. Amarji, Amar Srivastav ji. He is not present. D. Shravani. DVV Durgaveni. Kandar Fukan.
Yes, sir. Yes, sir. Kandarpa Fukan, sir.
Yeah. Please start. Sorry. Avoid experimental. Govind Prasad, he will get time today. No problem.
The participant who has unmuted himself, he is using two devices very near in a space.
Yes, sir.
So I request, just disconnect one device and share it via one device.
Yes, I have already done that.
Fukanji, please start. Unmute and start. Please share your screen and explain. Kandarpa Fukan. D. Shravani, please remain present.
Sir, VV Durgaveni Dasari sir. Can I present? VV Durgaveni Dasari.
DVV Durgaveni, yeah.
Yes, sir.
You are ready?
Yes, sir, I am ready.
Yeah, go on, please.
Thank you, sir. Sir, I'm started.
Yeah. Go on.
A very good afternoon to all the NCC present here. Hope you are all doing good. Stay safe and stay healthy. I am DVV Durgaveni Dasari, working as JRF BRNS project, Pragati Engineering College, under the guidance of Dr. PVS Machiraju. I am here to present a poster on physicochemical characterization of groundwater in West Godavari region of Andhra Pradesh. Just will have intro on groundwater. The groundwater is an essential source for drinking and irrigation purpose. In present day, the groundwater sources are losing their quality due to hectic anthropogenic activities. Next, I am speaking about object of the study. The main purpose of the study is focused on characterizing of groundwater to evaluate the suitability of water for drinking purpose. Then study area. Area of My study is focused on Andhra Pradesh State, West Godavari District, Eluru Revenue Division. In that, there are 16 mandals, out of which I choose only 4 mandals. This image represents my study area. This is India map, all are knows. Blue color indicates that Andhra Pradesh. Next, pink color indicates that my study area. This one. I will focus on methodology. I have tested 4 ways. First one, grid map preparation. Second one is water sample collection. Third one is sample analysis. Fourth one is generation of data. I would like to turn grid map preparation. Before sampling collection, grid map was prepared. Grid size 6 kilometers and 6 kilometers. Sample collection from each grid. Sample collected from both pre and post monsoon seasons. 23 samples were collected. Sources like open wells and dug wells. These are in situ parameters like pH, EC, and TDS salinity, which are tested in field itself. These are laboratory analysis. The results, coming up results, these results for all these parameters pre and post monsoon seasons and are compared with BIS standards. Most of the water samples within the permissible limits. Next goes with correlation matrix. Fluoride is highly correlated with TDS, EC, salinity, pre-monsoon season, and moderately correlated with TDS, EC, salinity in post-monsoon season, which indicates that water are saline in nature. And finally, conclusion, from which I observed that hence the water are to be properly treated with the available treatment methods to consider and drinking and domestic purposes. That's all about my presentation. Thank you for listening my presentation, and also I would like to thank ICT members, and I would like to thank R&D for giving a good support and guidance for this research presentation. Thank you so much, sir. So, completed my presentation, sir. Sir?
Mr. Russell, please unmute yourself.
You have completed, no?
Yeah, yes, sir, completed my presentation.
Okay, thank you, thank you.
Thank you so much, sir. If any questions, ask me, sir.
Sorry, no time for a question.
Oh, okay, sir. No issue. Thank you so much, sir.
Manisha D. Patil, Manoj Kumar, Naveen Kumar.
Sir, myself, D. Shravani, sir. I would like to present my paper.
Come, I am searching for you. Please, D. Shravani.
Oh, okay, sir. Okay, sir. Sir, I can't share my screen. Can you give the permission, sir?
Yeah, you
for
can
screen sharing.
unmute yourself.
You have your permission.
Next, Sunita Singh, be ready for the next presentation.
Yes, sir.
Shravani ji, please.
Sir, myself, I'm being ready, sir. So just I'm been sharing. So my work is related with the characterization of nutrients and
Your screen not visible, not screen not visible.
Yes, sir.
Shravani ji, time is very short. Please, hurry up.
Sir, actually, I'm being
No
sharing.
problem. You can wait. Sunita Singh, you ready?
Yes, sir.
Sunita Singh,
Yes, sir. Yes,
are you
sir.
ready?
Yes, sir.
Go ahead.
Sir, are my slides are visible?
No, no,
So now,
no, not.
so here is it showing.
Please share a screen first.
So I have shared this.
Yeah,
screen.
good. What is visible
Yes.
now? Please
Okay.
explain.
Thank you, sir.
Very short.
Yes, sir. First of all, a very good afternoon to respected dignitaries. The topic of my presentation is essential oils as a potential candidate of a food preservative, a step towards green consumerism. Green consumerism is the usage of products of a natural origin, and essential oils are the aromatic volatile liquids present as secondary metabolites present in plants. Essential oils are
Remain prepared, please.
currently gaining momentum due to broad spectrum of preservative potential. If we talk about the synthetic preservatives, they are found to be very expensive, as well as they are found to have residual toxicity and carcinogenic in nature. So essential oils come as a very good alternative. If we talk about the biochemical composition of essential oil, it mainly contains terpenes or phenolic compounds or sulfur derivatives. Next, the mode of action. The mode of action of essential oil contains degradation of cell wall, disrupts the cell membrane, leakage of cell contents, cytoplasm coagulation, interferes with functionality of genetic material, and inactivation of enzymes. And if we talk in conclusion, a number of essential oils and several of their individual components exhibit antimicrobial against many foodborne pathogens in vitro and to a lesser extent in foods. The phenolic components are most active and appear to act principally as membrane permeabilizers. If we talk about the future perspective, a nano encapsulation can protect the essential oils and their bioactive compounds from oxidation, thereby providing stability, controlled release of bioactive compounds, and we have to take care of the organoleptic properties of foods also. This is a figure showing the nano encapsulation of essential oil. Thank you for hearing me. Thank you, sir.
Thank you. Thank you.
Thank you, sir. Sir,
Shravani,
please give
is
me a
Shravani
chance, sir.
ready?
Yes,
Shravani?
yes, ready, sir. Sir,
Yeah,
ready,
good.
sir, myself.
Good.
Sir. Sir, my work is characterization. I can't share a screen I'm getting, sir. Please, sir. Please
No
help
problem.
me.
You go ahead.
So my work is
Ma'am,
characterization
you have
of
screen share.
characterization of nutrients and anti-nutrients from the mangrove region, sir. So my work is, so I've collected a few plants from the few species from mangrove region. So we know that in India, we are having the coastal region more. So that these mangroves plays a very important role in protecting from the coastal region from the tsunamis,
Govind Prasad, please remain prepared.
floods. So my work is to characterization of nutrients and anti-nutrients. So characterization of, sir, is it visible, sir?
Yeah, visible. Go ahead.
Yeah, okay, sir. Okay, sir. Thank you, sir. So characterization of mangrove plant extracts, its nutrients and anti-nutrients. So we also, in spite of protecting these coastal regions from the floods and other regions, so here these mangrove plants also plays a very important role because it is enriched with the drugs and various sorts of drugs and other molecules which are very helpful in preparing of pharmaceutical and other industries. So for my work, if you observe my work regarding this is to collect these plant extracts from the nutrients and anti-nutrients, so which are situated mangrove region from the especially in the Godavari and region so of Andhra Pradesh. So I have been analyzed to these samples. I have also found the these metals
So these through the methods like ICP-MS
वैसे मेरे
and
पास
for
भी है
analyzing of nutrient contents.
हाँ मेरे पास
So ICP OES also I have done the experimental data, and also I have for anti-nutrients I have been followed the titrometric methods for preparation of these samples. And also if you see the results and discussions, so I have selected the 3 species. In the 3 species I found that leaves, especially in the leaves, have been selected the part of a plant. So in that the magnesium content is more when compared with other nutrients. And also I have seen some rare metals or also very less percentage was found in this area. And also in the regarding the another plant extract, that is in this Sorreta epitela. So in this plant I found that a few leaves, manganese, aluminum, next boron, zinc are averagely accumulated in these plants. And other trace metals which are very less, that is heavy metals, cobalt, mercury and molybdenum, which is less than 0.1%. And coming to the third species, in the third species I found that very less concentration of boron, aluminum,
Yes,
iron
sir.
was found. And also trace metals are very less percentage, that is mercury, molybdenum, toxic metals are very less percentage I found in the third species also. And regarding these anti-nutrients, I've done the work in the different parts of the plants. So I found in the leaves, stem, flower and fruit, the concentration of oxalate content I have been found. So in that fruit content will be containing of a more oxalate
Conclude, please
content when
conclude.
compared to the other in the first species. In the second species, I found that a flower will be having the more oxalate content. And in the third species, I found that fruit, especially the fruit content which is having the oxalate content more. And also I've been having the phytic acid and vitamin C data also. Due to the lack of time, I can't represent here, sir. So overall, if you take in these 3 species, so Algocha tree is the one which is having the trace nutrients, and also it is having the high oxalate content, and it is also very important for the analyzing of work. And to this work can be represented for a pharmaceutical and other also it will be very helpful. So we can separate the oxalate content from the fruits, and also this oxalate content can be used as a complex for making of other applications, sir. So
Devi
this is my
Prabhu is
work,
not
sir.
able to see screen.
Sir, sir, is it visible, sir?
No,
My
he
screen
not.
is
He
visible.
cannot see. He not seeing.
Not seen. I've been sharing, sir. I'm getting a video that been sharing this screen, sir. Sir, I'm been sharing, sir. Is it visible, sir? Is
Yeah,
it
it is
visible?
visible. Please conclude now.
Okay. So this is the work regarding my work, sir. Regarding the characterization of nutrients and anti-nutrients, sir. So these are the oxalate content I have been analyzed in this 3 plant species. There are also nearly 35 plant species are there in that region, so which are a wide range of research work is being carried out, sir. So from this, I've been very thankful to the ACT coordinators and also the ACT members, and also especially my guide, that is a PVS Machraju sir, encouraging me to present a paper in the front of a conference, sir. So thank you, sir. Thank you, sir.
Thank you. Thank you very much. Govind is prepared. Mr. Govind Prasad, are you ready? No. Garima Nagaraj, are you ready?
Yes, sir. Yes, sir.
Yeah.
I'm ready.
Hurry up, hurry up. Time is short.
Yes, sir. 1 minute. Sir, I'm sharing 1 minute. Sir?
Yeah, share your screen and
Share your
start.
screen.
Yes, sir. Sir, 1 minute, 1 minute.
Yansi Bora remain alert and prepared. Dr. Archana Singh is there. Archana Singh, Sasi Bala, Nisha Garg, Mukta Rajotia.
Go to sharing.
Sir,
First, you open your this presentation. Open it. Just
Yes.
open it. Open it fully. This is
sir, it
open
is
it.
not opening now.
Ram Babu Parikh, sir.
Okay.
Are you
Yes,
ready?
sir, I am here, sir.
Yeah.
I can present.
Garima, you wait for some minutes.
Yes, sir, I'm trying.
Yeah. Ram Babu Parikh, sir, please.
Yes, sir, please give me permission to present.
Yeah, you can unmute yourself.
No, I have unmuted, but
Garimaji, please stop your sharing.
Someone is sharing.
Yeah.
Garimaji, stop your sharing.
Unshare.
Okay.
कर दिया मैंने stop.
Sir, is it visible to all?
No, sir. No, sir.
Now?
Yeah, now it is visible. Go on. Go ahead.
Good morning to all of you, sir. Sir, my presentation is based on challenges in online and digital mode of learning.
Really?
All we know that there are certain constraints due to COVID-19, and worldwide this COVID-19 is spread and just distract all the education system. So our present study is based on the survey related to challenges in online and digital education program. Although Government of India just initiated various activities related to online education and related to how to just start the teaching to our rural children. But in spite of several expectations from the government, there are certain constraints with government also. NCERT has developed several e-content from class 1 to 12. In spite of this COVID-19, along with the various stakeholders, 500 e-content has been developed, and that has been transacted day by day from September 1st. Even our Prime Minister, PM, Professor Dr. Shri Modi ji has inaugurated PM E-Vidya digital education program for the country. But in spite of all these things, the activity which the nation has carried out, there are several constraints. And this present paper is to pop up these challenges, to identify the challenges in online and digital. We have discussed the things with the principal, teachers, students at various level. And finally, some teachers reported that there is an inadequacy of availability of internet resources in schools, inadequacy of handling of equipment other than a smartphone for online classes, inadequate availability of human resources for operating the available internet resources. Even in rural places, there is very difficult to access the network also. Conducting online classes in rural area is its own challenges, and many students who do not have access to a smartphone or internet service get left out in this process. Some of the teacher also reported that less interest as most of the teacher shows their inefficacy in the process of teaching to online mode, lack of motivation in online with the students also, difficulties with online tools, and limited availability of these technological devices. Although our schools having desktop and somehow internet facility, but that is not feasible for online classes. That is only used for certain kind of thing for official work like that. And lack of familiarity. Some of the teachers reported that they are not familiar with the digital technology which they are using, and not being able to get affirmation about the student understanding. Lack of connectivity of all the digital devices required for the online classes. We have also talked with the students that most of the students do not having internet facility at home or their residence. through virtual mode, lack in learning the skill orientation for practical subjects, adaptability struggle is also there. Computer literacy is one of the bigger problem. Lack of self motivation. They are just understanding the thing isolation. No activity is there. No interaction is there. Self motivation is distracted among the students. Students also inform about their personal interaction is needed with the teacher to learn the things in a significant way. Lack of practice after the session is over, destruction of learning environment, lack of communication during online classes, lack of proper feedback from the student to the teacher. So with considering all these things, the government should initiate certain kind of guideline. Although NCERT has initiated certain guideline in the form of Pragya for online teaching practices, but there is a time to reform all these framework in a better way by considering the resources and internet connectivity related challenges. We have to solve all these things, because poor internet connectivity is one of the major challenge for digital education in India, especially in rural areas and some part of the urban areas. Mass number of population across India has still no access to internet, and has a large population in rural areas is still illiterate in the field of digital technology. So to make up digital education more interactive and robust, more innovations is required. Shortage of trained teachers also. Although teachers are there in the school, but they are not equipped with the digital equipment. Side by side, when we are teaching to upper primary level, there is a problem of language and content related challenges, because language, suppose NCERT is creating the digital content, then find that some kind of content is also required in regional language, so that is also missing. So language is one of the main barrier for the development of digital education in this country, and there are several different languages in different states have been spoken all across the country. So pushing all the digital content in all these regional languages sometimes becomes difficult for any agency. Poor maintenance and upgradation of digital equipment. I already discussed that there are equipments there in the school, but that equipments are not up to the mark. Their equipments, you can say, they are not upgraded. So in rural areas, maintenance and upgradation of digital equipment is one of the major challenge. This is largely due to budgetary constraint by the government. The digital education projects, although it is there, but it is not fulfilled up to the significant level. Insufficient fund is one of the major issue related to digital part of the online teaching. Second, quality. When we in one side we are creating the laboratory for chemistry, physics and biology, but now we are teaching through home or through online mode. So it means there is a constraint to have a hand-on experience by the student. So it is very difficult to understand the subject in which activity is required, and we are not able to give opportunity to provide the opportunity to the learner for hand-on activity. So in conclusion, I can say that we have to promote the online digital teaching only when we are having the sufficient kind of resources, whether it is in the form of Swayamprabha, whether it is in the form of internet, or some kind of pupil participation is required at rural places, so that can be increased. Thank you.
Thank you, sir. Thank you. Dr. Archana Singh, are you ready? Dr. Archana Singh, are you getting my sound? No.
Sir, I'm
Archana
ready.
Singh, not ready.
Sir,
Yeah, you're ready.
sir, I'm
Please.
Garima.
Garima, are you ready?
Yes, sir, I'm sharing.
Oh, good. After Garima, Dr. Archana Singh.
Sir, I'm unable to share. Someone else is sharing the screen.
Oh, Archana, you wait for 2 minutes. No problem.
Dr. Archana Singh is sharing her screen, so she may continue with her presentation, and then
sure,
Garima
sure.
ma'am can start.
Then Garima, yes.
Yes, sir, yes.
Archana ma'am, your screen is being shared. Please start with your presentation. Archana ma'am, you are not audible. Your mic is open, but we are not getting any voice from your side.
Marriage proposal in the crowd. It's on a big screen. Yes, absolutely.
Archana ji, we are not getting you. You are not audible. Hello, Archana ji.
Sir, I think she has some issue with the sound thing.
No problem, no problem. Please.
Archana ma'am, please, would you just stop your screen share so that Garima ma'am can share her screen? Since, yeah, thank you so much.
Yeah, very good. Garima, please. Hurry up. And next will be Professor Dr. Amar Srivastav ji. If anyone is willing to present,
So myself, yes, sir.
we have to wait for 4:45. Garima is there? No.
Yes, sir. Yes.
Garima ji, please unmute yourself and share your screen.
Yeah, time is running short.
Sir, myself, Sudipta Sutia, can I present, sir?
Wait for some time. 2:30, we have to start Mr. Javier's speech from abroad. So, we should start.
My name is there actually, sir.
Yeah, we shall start presentation again at 4:45, no problem. If anyone wish to present,
Okay,
they will be given chance. No problem.
Okay, sir. At 4:45, right, sir?
Yes, sir. Yes, sir.
Yeah, 4:45.
Okay,
All those who wish to
Okay, okay,
present will be given chance at 4:45. Amarji, you are ready? Amarji is there? No. Shyamji, are you ready?
Sir.
Yes. Amarji ready. Started. Good.
Amma sir, we are not getting your voice. Amma sir, we are not getting your voice. Mishra sir, do you get Amma sir's voice?
No. We are not getting. Amarji, we are not getting you. We can take 1, 2 more, no?
Sir, Amar sir has stopped.
Yeah. Anyone is present there to?
Myself,
Yes,
Condor
sir, my
Pafukan,
name
am I present?
You are?
Condor Pafukan, sir.
Yeah. Go on.
Amar Srivastava has again started saying.
Then wait for it. Amarji, we are not getting you.
Can I present, sir?
Amarji has again shared the screen. Let him conclude.
Sir, can I present?
Sudipta,
Pukanji, you are ready?
Sudipta, sir, yes, sir. Can I present, sir?
Yeah, start.
Yes, sir. Thank you. Sir. Yes. Yeah. My name is Sudipta Satia, and I'm from Guwahati University Research Scholar. I'm doing PhD work from under the supervision of Condor Pafukan, sir.
Your screen not visible.
Now visible, sir?
Yeah. Your name, please.
Please tilt your screen. Please rotate your phone so that it will be in a.
Sir, can I present?
Yeah.
Yes. So my ministry.
Sudipta. You are Sudipta.
Yes, sir. Sudipta. So my manuscript title is electrically conductive polyaniline coated nasal fiber used in electronic devices. So in my introduction part, I used to introduce polyaniline, which is a conductive polymer used in chemical laboratories since 1910. And second one is the cellulose fibers, which is an indispensable part role in my manuscript, because the cellulose is a macromolecular polysaccharide polysaccharide is composed from glucose. And important thing is that cellulose is widely available in everywhere, and cellulose fiber, and it is renewable and it's biodegradable. Next one is conductivity of polyaniline coated cellulose fiber. The two important points I introduced. The one is preparation method, which there is a different types of preparation method used by different scientists. But the C2 oxidative polymerization method is very useful because it's easy to synthesize. Next one, the thickness of the cellulose fiber. The thickness is inversely proportional to the cellulose fiber conductivity, because if we thickness decreases the thickness of this cellulose fiber, increases the conductivity of this polyaniline coated cellulose fiber. Then we discuss about main part of this manuscript, electronic devices, which basically prepared by polyaniline coated nasal fibers. So first one is biological sensors. Basically, biological sensors are mainly function to detect the small particles, protein and DNA utilizing. So in 2017, Bakri and his team introduced a biosensor which basically detect the hepatitis B virus. So it's with low detection limit of 1 FM. Next one, in 2019, Sore and his team introduced a biological sensor which detect the uric acid. In 2015, Hong and his team introduced different type of biological sensors like strain sensors, pressure sensors, temperature sensor, and oximeter. Then there's supercapacitor. We know that supercapacitor is a device which actually stores the energy. So in 2014, Lee and his research team will introduce polyaniline coated bacterial cellulose multi-wall carbon nanotubes capacitor, which give very good capacity, specific capacitance, 656 farad per gram. In 2015, Yang and his team will introduce the aerial supercapacitance, this carbon nanotubes, whose aerial capacitance is very good, is 0.33 farad per centimeter square. And then this touch skin is a which we use in our Android mobile or something else nowadays. So the Ragajani in 2020 he introduced first cellulose pani coated cellulose touch sensors, which gives very good property, like its fast response time at 52 milliseconds. Then starting electric capacity increases 3 to 4% after the compressing. Then the actuator, we know the actuator is a device which which causes machine. So in 2019, Sun and his team and co-workers introduced a nasal biopolymer gel-based actuator which have better quality, like quick response time and 10 seconds, small impedance, effective resistance is very small, 2.941 ohm. Then energy density is very high, 198.33 to 521 watt-hour per kg. So last electronic device I will explain is electrochemical sensors, which nowadays very broadly studied, is the pH sensors. So in 2017, the pH sensors Aldaba introduced an optical and fiber optic pH sensor, which have maximum sensitivity of 82 picometer per pH and minimum sensitivity of 30 picometer per pH. The Europe maximum sensitivity 82 pH is 2.91 pH and minimum sensitivity Euro is 0.64 pH. After that, my conclusion part is yes, sir. I concluded that in different types of nasal fiber used in different types of electronic device, such as bamboo, pineapple, big gas, cotton, poplar, and fiber. These fibers are coated with polyethylene. Then it will be used as used in electronic device, which are discussed previously. Then it was expected to see more kind of novel nasal fibers to be combined with funny and application in electronic device to enhance the sensitivity. Thank you. That's all.
Thank you. Anyone ready? Next.
Can I present, sir? Can I present, sir?
Yeah, if you are ready, you can present.
Naveen Kumar, please share.
Yes, sir. Yes, sir.
Can I present?
Hello, sir.
I request all the other participants to please mute yourself, since you are.
Are you hear me, sir?
Yeah.
Sir, Naveen ji, please wait for a second. I request all the participants to please mute your mics. If you continue to remain unmuted, you will be having a humming sound and having a echoing sound. So it's a humble request to all the participants that please keep your mic on mute. Naveen ji, you can start.
Okay. Today I am giving my paper 2 mercaptan-benzimidazole ligand based model of FFA hydrogen synthesis and characterization electrochemical studies from the lab Bioinorganic Research Laboratory from Department of Chemistry and University of Delhi. Now the introduction part. The biological hydrogen produced by the group of amylase enzymes known as a hydrogen, which is basically found in the cyanobacteria and bacteria algae, and hydrogenase enzyme which catalyze the generation of a dihydrogen by reduction of a proton at lower orbital potentials with high Tron number. Here I reported synthesis, characterization, and electrochemical studies performed for as a bio-inspired mimics of a FFA hydrogen active sites. In the result and discussion part, I start from synthesis. I synthesize complex 1 and 2 by reflexing of a 2 mercaptan-benzimidazole in with triene and 2-decacarmylane in the ratio 1:2.2 4:3, or in argon atmosphere gives complex 1 and 2 with precurrent complex A. I try to make complex 2, but unfortunately I get complex 1 in major quantity. I also get the crystal structure of a complex 1. The structural structure of a complex 1, which is already reported in complex in Chinese Journal of Structural Chemistry in 1992. But here I study the electrochemical part of this compound. The characterization of the complex 1-2, the FTIR spectra in complex 1 there is a 4 peaks due to the terminal carbonyl ligand present in the complex 1, and the in complex 2, there is a three symmetrical carbonyl ligands present in. Due to this, it gives 3 carbonyl peaks. Complex 1 and 2 showing the UV spectra in DCM and acetonitrile due to DD transition showing by these complex. Now, the electrochemistry part of this complex, complex 1, CV4 cyclovoltagram of complex 1. It is the graph between current versus voltage. When increasing acid concentration, the current increasing. It shows the highest catalytic activity in trifluoroacetic acid. The second graph between current versus voltage, there is a comparison between 84 millivolt TFA, blank TFA, and 84 millimolar TFA with complex and black only complex. These are the comparison between, which showing the what is the effect after adding the acid and without acid. In the table 2, I represent the catalytic peak. Complex 1 showing the catalytic peak around minus 1.68, but when acid used in trifluoroacetic acid, it gives 2 catalytic peak, which is around minus 1.73 and minus 2.02. In figure 5, there is a graph between IP versus under root of square net, which gives the diffusion control activity of a complex 1. Now the graph between IC versus acid concentration gives the second order, the slope gives the second order reaction shown by the complex 1. Now the graph between K observance and acid concentration gives the first or second order dependence on the acid concentration of a TF acid. Now the conclusion part, tri-iron nuclear complex was found to be electrocatalytic active catalyst due to it has it gives the low ore potential, which is around 0.85, and high in the catalytic efficiency in the range between 0.75 to 0.25 with K observance 1350, which is known as a Turner number. I especially thankful to CSR and for my project and UGC. These are the references. Thank you.
We can take one more. Anyone is ready? Last one. Only one.
Can I present, sir? Can I present?
Yeah, present.
Okay.
You are Gyansri Bora.
Yes, Gyansri Bora.
Okay, good. This is the last, and now after 4:45. Yes, start, please, Gyansri.
Thank you, sir. So, considering the theme of the conference, which is sustainable chemistry and its key role in the society, I have selected my topic under the sub-theme recent advances in green synthesis and analytical techniques. So, my topic of my presentation is water-mediated green synthesis of skip bases under CES, which is calcinated excel under sonication, antioxidant, and ion sensing properties. So, first, we know skip bases are very much important and they have a huge level of uses. They can be used as catalysts, industrial purposes, they have medicinal properties, and they can be easily to synthesize, as well as they're very less expensive. So nowadays, demand of skip bases is very high. So considering the fact we have synthesized different bases from 2,3,4-trihydroxybenzaldehyde and different aromatic diamines, and also we have given importance so that we can synthesize the skip bases as greener as possible. So for that we have used XL powder, which is calcinated in a muffled furnace at 700 degrees. Yes, and also we have used water as the medium, and to make it extremely green, we have used sonication as the method, and we have seen that under the optimization process, we have seen that in sonication under using water and calcinated Excel, we have found extremely very good percentage yield of the product, and also we have compared different methods, and also we have used other organic solvents as well, and we have seen that when water is used as the solvent and sonication is the process, we found the very best product yields. And these are the yields of my different 5 skip bases using sonication process using calcinated Excels. So after the synthesis process, we have given importance so that to know how we can use our skip bases. First, we have determined their antioxidant activities. We have used 2 methods: DPPH radical scavenging assay as well as ABTS radical scavenging assay, and we have used different solvents so that to find their best antioxidant activity in DPPH assay, and we have used methanol, DMSO, acetonitril, ethyl acetate, diethyl ether, and chloroform, and we have seen that methanol worked as the base solvent when the antioxidant activities are tested, and we have seen that skip base 1, 3 and worked as very good efficient antioxidant by following both the 2 methods, and all the synthesized skip bases worked as far better antioxidants than their corresponding parentaldehyde. Then we have tested their ion sensing activity. We have used different anions as well as different cations for the naked eye detection experiment at first, and we have seen that color things occurred. Cyanide was to the skip base 1, which was synthesized from 2,3,4-trihydroxybenzaldehyde as well as 1,2-diaminobenzene. And then we have done the UV visible titration experiment, and we have seen that 1:1 complex formation was depicted by UV visible titration experiment. We have also done the selectivity test for the UV visible titration experiment, and also
okay,
I was, yeah. Can you, am I audible? Okay, thank you.
Yeah.
So after the UV visible titration experiment, we have plotted, we have used job spot to confirm the stoichiometry, and we have found 1:1 complex formation. Thereafter, we have used fluorescence titration study to further check their ion sensing activity, and also we have seen 1:1 complex formation in fluorescence titration studies as well. We have used a selectivity test. We have done the selectivity test for fluorescence titration study as well, and we can clearly see that cyanide was clearly sensed by the skip base, whereas other ions are not being sensed. So the limit of detection is 1.1 into 10⁻⁻8 molar, which we can say that it is very low compared to various other available cyanide sensor, and association constant is also very good. To understand the mechanism, to know which of the groups in the skip base is being utilized in the sensing process for cyanide, we have done the NMR titration study, and we can see that the OH peak, specifically the hydroxyl peak, the proton peak of the hydroxyl group was decreasing at first also, and at the last it is diminished. It is completely invisible. Okay, so we can say that the hydroxyl proton is being used in the bone formation with the cyanide group. So we can say that we have used a very green method of sonication using water as the medium, and calcinated Excel, which is a household waste catalyst, which is available in every household as a waste product. We have used that as a catalyst and synthesized skip bases. They are very good antioxidant compared to the parentaldehyde.
Sir, Xavier has joined, huh?
Okay, one of them can be used as a cyanide sensor. So thank you very much for the organizers for giving me the opportunity to present my.
Any other wish to present paper should wait till 4:45. We have 3 lectures, and after that you can present. Now, Nayanji, please. Nayanji, please take over the.
Hello.
Yes, sir.
So before Mayank sir, before that I will be muting all. So who is going to take? Convey this? Anybody, sir?
Mayank Kamal, Sudha Jain ma'am, Professor Xavier Garcia Martinez, Professor Tom Welton, and Dr. Ankush Gupta.
Okay. So, sir, I'm just muting them. I have provided co-host rights to you, Dr.
Yeah.
Xavier, Dr. Brajesh Pare,
Yeah.
and Dr. Krishnamurthy. So, yeah, I'm just providing a forced mute.
Mr. Sir,
Xavier Garcia Martinez.
Mr. Sir,
Yes, sir.
this session will be chaired by Sudha ma'am
Oh,
again.
yes,
or-
Sudha ma'am. Yes, Sudha ma'am. Sudha ma'am.
Yeah, you unmute yourself. Unmute. Mishra ji, Dr. Mishra, unmute yourself.
Yes, sir. Yes, sir. Yes. Hello, Xavier sir. How are you?
Hi.
Are you fine?
Good afternoon, Dr. Martinez.
Good afternoon.
Yeah.
Kamalji, please.
Kamal and start, please. You unmute. You have to do it. You unmute yourself. Sunny, this Nayan Kamal has been unmuted now.
Yes, sir. Now he can unmute himself.
Now you unmute yourself.
Sudhajan ma'am. Sudhajan ma'am.
Ma'am, sir, she can also unmute herself. I have also provided her co-host rights.
Sudha ma'am is there?
Yeah, I'm here.
Yeah. Good man.
Yeah, good afternoon, everyone.
Yeah.
Good afternoon, everyone. Now we have the second session of the today's event. In this session, we have three invited lectures. There is the special invitee, the first Professor Xavier Garcia Martinez. And I would again request Sudha ma'am to chair this session. But before that, I request Professor Xavier to release the periodic table based on discoverer, year, and place of discovery designed by Dr. Subhas P. Singh, Department of Chemistry, AN College, Patna, ACT Zonal Secretary, East Zone, and National Coordinator of Concept Test in Chemistry. I request Professor Xavier to release this periodic table. And by the time I request Professor P.M. Mishra to share the screen.
Screen visible to you all?
Yeah, it is visible.
Yeah. Very good.
SP Singh is there.
Subhash ji.
SP Singh.
You should clap hand now.
Yeah. And
That is.
Dr. Bipul Saha is also here. You know, we are lucky to have Dr. Bipul Saha, who is an IUPAC representative, you know, and a good friend of Dr. Martinez.
Oh, good.
Yeah, he is there.
Welcome.
Yeah. Sir, welcome, Dr. Saha, Bipul Saha.
Shall I start?
Sunny, yeah, no, it is there. You know, this is the release of the periodic table of Dr. SP Singh by Dr. Martinez.
I think we may tell the specific points about this periodic table.
Dr. SP Singh is here. Anyway, this is the periodic table, as I was told by SP Singh, that the name of the place of the person who discovered the element is also incorporated. So this is very important. It is very important because Xavier Martinez is releasing it, and he is the president-elect of IUPAC. So thank you very much, sir. Thank you.
I'm not releasing it. I'm not endorsing this. It's something you said to me.
Yeah.
IUPAC has its own periodic table.
Yeah.
So I'm not releasing it.
Yeah.
You are sharing it.
Okay. Yes, it's fine. Okay.
I think
you should go ahead.
Should start the.
Sudha ma'am, I request you to place on the.
Thank you, Professor Nayan. Very good afternoon. to all present over here.
Anji, please
Welcome.
stop sharing.
Yeah.
Yes.
I, on my behalf and on behalf of ACT, welcome Professor Xavier Garcia Martinez to this 3 days international workshop. Professor Martinez is a professor of inorganic chemistry and he is director of the Molecular Nanotechnology Laboratory of the University of Alicante, where he leads an international team working on the synthesis and application of nanostructural materials for the production of chemicals and energy. He is a co-editor of the book Chemistry Education, published by Wiley in 2015. Xavier is also president-elect, president for the biennium 2022-2034 of the IUPAC. Previously, he has served as member of the executive committee and as vice president of the division of inorganic chemistry. He is founder of the technology-based company Rivet Technology. This company markets the technology which he has developed during his Fulbright postdoctoral stay at MIT. Since 2012, the catalysts which Rivet Technology sells are used in several refineries, significantly increasing fuel production and the energy efficiency of the process. In 2019, W.R. Grace has acquired the Rivet Technology. For his work, he has bagged several awards. To mention a few, in June 2014, he was awarded the King James I Award in his category of New Technologies. And in 2015, the Emerging Researcher Award from the American Chemical Society. In summer of 2017, Xavier was recognized by the American Chemical Society with the Catherine C. Hash Award as the best U.S. entrepreneur in the chemical sector. Xavier is a member of the Council of Emerging Technologies and Young Global Leader of the World Economic Forum, of the Global Young Academy, and Fellow of the Royal Society of Chemistry. He is also President Academia Joven de España, AJE. So we are having today not only the academician, but entrepreneur. So a blend of both the academician and entrepreneur, which the youngsters want after their career. So with these few words, I welcome you once again, Garcia, and I invite you for your presentation. Garcia, please.
So thank you very much for the very kind introduction. And on behalf of the International Union of Pure and Applied Chemistry, IUPAC, I want to congratulate the Association of Chemistry Teachers of India in your 20th birthday. I know you have 20 years of history, and I wish you, on behalf of IUPAC, all the best. I also want to congratulate all of you on behalf of IUPAC for this wonderful national convention of chemistry teachers. And I thank you personally for the opportunity to address all of you. I know you have a lot of students in the audience and a lot of chemistry teachers, and IUPAC is very prominent in the chemistry syllabus. And probably most of you don't know anybody from IUPAC, so it's my privilege to put a face on the name of IUPAC and address this audience. So the topic of my presentation, which has the title Chemistry Evolved, so should chemistry education, is the theme of a recent guest editorial that I wrote for the American Chemical Society news magazine, Chemical and Engineering News, by the title of The New Chemist. I want to just share with you how I see chemistry evolving. And in the last few years, we have witnessed an incredible discoveries that has been achieved thanks to machine learning. And I want to share just a few examples to provide just examples of how quickly chemistry is evolving. This is a very good example of what I'm saying. This is a recent paper in Angewandte Chemie where computers, humans, and just random experiments were able to conduct 100 experiments to produce novel polyoxymethylates. So for these 100 experiments, both the humans and the machines were able to analyze the results every 10 experiments. So they have 10 opportunities to design experiments that will cover the chemical space and that will finally lead to better materials. Of course, the control experiment is just carrying out those 100 experiments without any design. And the results are quite significant. As you can see here, the machines has outperformed scientists in their ability to design experiments, but also in exploring the chemical space in a much more efficient way. So with this simple set of experiments, the authors of this paper have shown that by using algorithms, machines are very good at designing experiments based on the data they have. A minute ago, you presented a periodic table. I want to present this one. This is the IUPAC periodic table, the most recent one. And as you know, it took us hundreds of years, to humanity, took us hundreds of years to reach to this wonderful periodic table that we all study, and it's probably in all the chemistry classrooms around the world. So last year, a group of scientists allowed computers to read thousands of papers and trying to create their own periodic table where computers will group elements based on the physical properties and on how they interact chemically based on what they read, what they learn from those scientific papers. And this is the result. As you can see here, this was a paper published in Nature last year. Of course, on the right is our periodic table, the most conventional one. And on the left, you can see this periodic table that was produced by computers. You may think it's a little bit messy, but if you analyze that periodic table, it's amazing what computers learn and were able to produce in a matter of hours, not in a matter of centuries. It took us to produce the periodic table. First, machines were able to group all the alkaline elements very nicely, and actually to see the ones that have more similarities and put lithium a little bit off. And of course, francium, as we will see, is really off. All the radioactive materials are very off because their main properties are different from the rest of the group. Of course, for radioactive materials, probably that is the most important feature, at least that's how machines saw it. Same thing for noble gases. Computers, in a matter of hours, were able to identify all the noble gases and group them together. Okay, hope you can listen to me. So more interesting things happen when now we talk about group 13, that of course in our periodic table, they are all grouped in the same category, but there are main differences within this group. Our machines were able to group elements in group 13 according to the properties, which are actually quite different because they contain both non-metals, semi-metals, and fully metals. Now, if we look at how the semi-metals are grouped in this periodic table produced by computers, we see that they share many, many common features that our periodic table is unable to highlight. And of course, this periodic table by computers group together all the radioactive materials, which which is a feature that in our periodic table is not clear. It's not clear where all the radioactive materials are, but here we have elements from the alkaline metals group, from the alkaline earth metals group, and all of them share that property, which again is not highlighted in our conventional periodic table. So computers are very good at designing experiments and identifying common features within the chemical elements. And more recently, and again, this is a paper published in Nature actually this year, they're also very good at performing experiments. This is a robot which is able to perform the whole set of operations that you need to carry out in a lab, from the synthesis of the compounds, weighting the compounds, analyzing the different products. So this mobile robot, again, was a paper published in Nature this year, was able, as you can see here in this graph, to perform hundreds of experiments just in a matter of a week, just a little bit over a week, and actually improve the catalytic performance of this material with all these chemicals that he was given to experiment with, and improve the catalytic performance of these materials by a tenfold. So experiments, these papers that I highlighted with you show very clearly that now computers and robots are able to outperform humans in designing and performing chemical experiments. So while machines are learning very quickly and are able to outperform chemists in many different ways, we keep teaching chemistry in the same way that we did decades ago. This is the contents of a typical chemistry book that many of you will be studying. We start with mass conservation, atoms, electrons, bonds, molecules, and then maybe we go to reactions, redox reactions, acid-base reactions, and then a little bit of inorganic chemistry, and that's about it. This image that I'm showing here is from a very recent book that was published just last year. But you couldn't tell from which year this book is, because these contents has been the same for decades. So all these wonderful discoveries that we are seeing in chemistry, they are not incorporated in our textbooks. The content is irrelevant. It can be from a decade ago, it could be from 20, 30, 40 years ago. We will see a textbook with the same content regardless of all the wonderful discoveries that has happened in the last decades. And that's really a pity. So in terms of content, we are not evolving in how we teach chemistry. But also in the way we teach chemistry, we are not evolving. We are teaching chemistry in the same way has been taught for many, many years. Here I will say for over a century. And how is that? So there is the way chemistry is taught is with one person sitting on a stage talking to hundreds, sometimes dozens, hundreds of students, like if every single student will have the same learning ability, skills, needs, interests, and actually is not that different from how chemistry, or for this matter, any other subject has been taught for centuries. So science in particular, and science in general, and chemistry in particular, needs to be taught in a very different way, keeping in mind that everybody's different. And that's kind of my main message. Computers are all the same. Robots perform all in the same way. If you program them in the same way, they will react similarly. But our students are different. And actually, diversity is something that should be embraced and encouraged in our classrooms. So that is my main message. we need to adapt the contents of chemistry. So all these new discoveries are now part of our syllabus. For example, artificial intelligence, algorithms, robotics, how these things are changing chemistry, how chemistry is a human endeavor, how chemistry is key in achieving the sustainable development goals, the role of chemistry in solving climate change. All these things that I just mentioned that you know are very important are not incorporated in our classrooms. They are not taught, and that should change. And the other thing, the thing that should also evolve is how we teach chemistry. And then the main message is to treat every student differently, because every student is different, and actually that's a good thing. Diversity should be encouraged and should be also embraced. That was the main those were the two main points of my book, Chemistry Education. That was a major effort. This book here is a very comprehensive book with more than 30 chapters that covers everything from best practices to new opportunities and technological trends in chemistry education. That was forwarded by Peter Atkins. And here again, I made an effort to explain first that the contents of our chemistry courses have not changed for decades, and also the way we teach chemistry has changed very little. And the other key message from this book, and something that again I want to share with all of you, is that chemistry education as a discipline has evolved as a major discipline within chemistry and within education also. And now we have evidence of better ways of teaching chemistry. So chemistry education is providing us a roadmap on how to better teach chemistry. Now we have evidences, we have data, and we have experts that know how to change the way we keep teaching chemistry. And the pity is that with all this knowledge that the expert in chemistry education has been sharing with us for many years, chemistry is still in most schools taught in the same way. I'm not saying that there are not wonderful examples of chemistry teachers that are doing very innovative teaching. Of course they are, and I'm sure here in this Association of Chemistry Teachers, you have been sharing best practices about chemistry education, and many of you will be real champions in all these new techniques about how to better teach chemistry. But I'm speaking about the vast majority, where chemistry all around the world is taught in the same way that 100 years ago, and the contexts have not changed. So now I would like to share with you what we do at IUPAC, and I want to recognize this group of people, which is our Committee on Chemistry Education. This picture was taken a few years ago in Istanbul, and you already recognize Peter Mahaffey. He talked to you some time ago, a few hours ago, and this group is a really wonderful a group of people really devoted to chemistry education and to change how our discipline is taught. One of the things that we do is chemistry programs all around the world, like the Global Water Experiment that we organized for the International Year of Chemistry. But also we do recognize the best young scientists. This is a picture of the ceremony where we presented the Solvay IUPAC Award to young chemists. And again, every year we select a few young talented chemists from all around the world, and we recognize them in our main General Assembly once every 2 years. Also, we do recognize the best, the most distinguished women in chemistry and chemical engineering, and I encourage India also to nominate women that should be recognized for being champions in chemistry or chemical engineering. We need again, to recognize also the contributions of women to our discipline. And this is a picture of some of the awardees that got this recognition last year. More particular about chemistry education, last year for the International Year of the Periodic Table, we launched the Periodic Table Challenge, which is an online game to learn more about the periodic table. I invite all of you to go to this website and be part of the Periodic Table Challenge. You can get different levels and learn about different things about chemical elements. There are many questions, more than 300 questions, and it has been an extremely successful initiative where literally hundreds of thousands of people from all around the world have been playing and learning about chemistry, the periodic table, chemical elements. This has been so successful that we the IUPAC decided to continue this initiative, and now we are in the periodic table 2.0, and it will be last for much longer than just the International Year of the Periodic Table. And I want to congratulate India, because India has been the most active country in the Periodic Table Challenge, and actually by far. I know you have a very large population, but also a lot of interest in science and technology, and that is very clear by the number of participants in the Periodic Table Challenge. So on behalf of IUPAC, congratulations to all of you, and since there are a lot of chemistry teachers in the audience, I want to invite all of you to play and put India really on the very, very top of this international challenge. So congratulations. Mumbai has been especially active, I have to say. But what do we do at IUPAC? Well, we do a lot of things. The most important thing we do at IUPAC is to create the language of chemistry, but also to produce critically assessed data. That's very important. So we all have the constants, the toxicity data, the atomic weights, all those data needs to be produced. People need to go to the lab and actually find all that data, and that's what we do at IUPAC. And I want to recognize all our volunteers for going to the lab and helping us to produce all that critically important data. You know, atomic weights, how many times we use the atomic weights. So that's something we do at IUPAC, and we do it for free for all the chemistry community around the world. This is a very important website. That's why I want to share with all of you, especially our students and the chemistry teachers. This is goldbook.iupac.org, and here you can search for any item. If you have a doubt about what, for example, a chirality means, you just type here chirality, and then you will have the IUPAC definition on that, and will give you extra information about the constant sources. Again, if you don't know how to measure radioactivity, for example, here are the definition of the Curie, which is not an international system unit, but it's highly used. Again, wonderful source to get data. And I want to tell you a little bit about what's happening in IUPAC for the future. You know, what's in the future for IUPAC. And there I want to share with you what we are doing to create a chemical language also for machines. How we at IUPAC are empowering artificial intelligence, machine learning for chemistry. So in order to do that, we and our partners have created INCHI. INCHI is the International Chemical Identifier, numbers and letters that code for a particular molecule, and that code contains information about the composition, the bonding, and the 3D geometry of the molecule. So these very complex series of numbers of letters is a very effective way for machines to understand, for example, in this case, caffeine, right? Because in these series of numbers and letters, so the machine can understand, where is the molecular skeleton, the composition of the molecule, but also the stereochemistry, there are different isotopes, and finally any extra information which is required. So at IUPAC, of course, we create the language of chemistry. That's something that I'm sure many of you are aware of, and when you teach chemistry nomenclature, of course, you mentioned IUPAC, but now we are doing the same for machines. So we are going to empower all those discoveries that I told you at the beginning of my presentation. So now machines can help us to make even greater discoveries. I also mentioned to you how important is for us diversity. And that's why already last year, we launched the Global Women Breakfast. And this is a wonderful, wonderful initiative that we lead at IUPAC. And during the International Day of Women and Girls in Science, at IUPAC, we create these online global breakfasts where women from all around the world connect through our online platform to share experiences, initiatives, and different ways to promote women in science and in chemistry in particular. You can see here an example of some ladies from Portugal, in this case, that were sharing their experiences and some information about how they feel and the barriers they encounter in chemistry and how we can help them to overcome those limitations. And these are some wonderful pictures that we got from all around the world during that global breakfast. And I want to leave you with this image because this is the best image of IUPAC. I know when you introduce IUPAC to your students, it's probably tell them about the periodic table or maybe about nomenclature, but we at IUPAC do many, many other things. Not only produce critically important data, but also encourage chemistry education, chemistry diversity, and also the chemical industry and enterprise. Just as a final reflection, this is an invited article that Peter Mahaffey and myself wrote for Chemistry International, where we discuss some of these ideas. So to summarize, chemistry has evolved a lot. We are all aware of the major discoveries, how machines are outperforming chemists, both in designing experiments and in performing those experiments. So we need to change education. So the kind of skills and content that our students will need when they will become chemistry professionals need to be different from the ones that we learned 10, 20, 30 years ago. Unfortunately, when you go to the textbooks, the content, what we are teaching is 95% the same that decades ago. And the way we are teaching, in most cases, I'm not saying in every case, because I know there are champions. I'm sure within this conference, there will be many of your champions. But in general, chemistry starts with just one professor, one teacher, and speaking to all the students, if everybody will be the same. And we need to promote diversity and to make sure that we understand that every student is different. So with that, again, I thank you for your interest from this very kind invitation. And again, congratulations again to the Association of Chemistry Teachers of India for your 20th anniversary. Thank you very much.
Thank you, Martinez, for this wonderful talk. First of all, I would like to have some questions, if any. Participants?
Participants, you may raise your hands or you can just write your question in a chat box. Okay. Please unmute yourself, Neer Shirkiwal.
Neer Shirkiwal.
Well, I want to thank you everybody from the very kind comments in the chat. Thank you very much. I'm glad that you liked my presentation. Very kind remarks in the chat. Thank you.
Oh. Professor Savita has a question. Can you give some suggestion for breakfast program for women? The question is in the chat box.
If I can give some advice on what? Can you repeat the question? So I couldn't hear it.
Asking about the
breakfast
program for women.
For women.
Yeah.
For women, what?
How it is going to be organized? How it is to be organized like that?
The global breakfast that I mentioned?
Yeah, she has mentioned breakfast program.
Yes. Okay. So on February 11th, every year, there is a global women breakfast, which is online. The only thing people need to do is to go to our website, ayupac.org, few days before and register. And then during that day, you can connect online through our platform. Again, it's on ayupac.org. Maybe since I'm sharing my screen, let me show you that because it's very easy. So if you go to ayupac.org, it's right here. I will share my screen again. I hope you can see the AYUPAC website. This is the periodic table challenge I mentioned a minute ago. This logo here is for the Global Women Fest. So you click here, that will be on February 9, right? Because of the weekend. So February 9, a few days before that, you come here, you register, and then you can share your pictures through a Flickr account. You can send information about the initiatives to our Global Breakfast at ayupac.org email, and there are representatives in many countries. And actually, Vipul is our representative for India. So if you have any questions, you can contact Vipul directly, or also you can contact us at AYUPAC here at Global Breakfast at ayupac.org. I hope that is clear. Okay, any other question?
How much time required to name a new molecule or compound by AYUPAC? This is another question.
Well, so we do have guidelines. So where there is a new molecule, you just need to follow the guidelines. It's very well established. And now it doesn't matter how complex is any new molecule. There is already a very clear roadmap to name any molecule. Actually, there is software available, so you have that also. That will help you. But again, if there is a new molecule and you want to name it, there's already guidelines to do that. You don't need to come to AYUPAC to do that. You just need to follow our guidelines.
I think Dr. Kandarpa is asking about the name of the book you mentioned in first part of the lecture.
Oh yeah, it's called. I will share my screen once again. It's just called Chemistry Education. Very easy to remember. I will come here. It's by Wiley. I will go back to where I talk about the book. It's right here. It's called Chemistry Education by Wiley. Is the only one. But if you type my name, Chemistry Education on Wiley, you will find it. The whole title is Chemistry Education, Best Practices, Opportunities, and Trends. But with Chemistry Education Wiley, you will get it.
Dr. Martinez, I have this book with me.
Oh, okay. Yeah. How do you like it?
Yeah.
How do you like it?
No, it is wonderful, and on the basis of some of the articles, I wrote one email also. I went through they're very good, wonderful. All articles are timeless. They are timeless. Very good.
Thank you. It's almost like a Bible of chemistry education.
Really, yeah.
Really
They are timeless.
With almost more than 30 chapters. So that's why I have such a broad title, chemistry education, because and I need to thank my colleagues at IUPAC, because many of my co-authors in the book are members of the Committee on Chemistry Education. So this is a collective book with many authors. I couldn't write it just on my own, and I want to thank all my colleagues at IUPAC.
Someone is asking, is the book open access?
No, it's not open access.
It's not open access. Okay. I think no more question I can see in the chat box. It is empty now. So, thank you very much, Professor Martinez. It was really a very interactive session. A lot of questions, lot of interactions. So you have opened everything. Now it is very clear.
Okay.
And
so what's
real science.
Yeah.
You dealt with
thank
very
you again. You back put a face, and I want to thank you to Vipul, which is a member of our bureau and is doing a great job promoting chemistry in India. So have a wonderful convention, and again, congratulations on your 20th anniversary.
And I think.
Thank you very much.
Thank you.
Thank you.
The second speaker is there. We have the second speaker for this afternoon, Professor Tom Welton. He is there, Professor Tom Welton.
Sir, ma'am, he has just joined in. So, yeah.
He has joined us. So I may introduce him, right?
Yes, ma'am, you can introduce him.
Okay. Tom Welton, he is a professor of sustainable chemistry at Imperial College London and he is Dean of the Faculty of Natural Sciences. He has served as head of the Department of Chemistry from 2007 to 2014. He is a fellow of Royal Society of Chemistry. Walton's research focuses on sustainable chemistry with particular focus on ionic liquids and on solvent effects on chemical reactions. Walton is openly gay and is active in advocating for greater visibility for members of LGBT community in the sciences. He is a member of the OCRI Equality, Diversity and Inclusion External Advisory Group. He is also a trustee of the Lloyd's Tricentenary Research Foundation. Since 2013, he has been a member of the Council of Royal Society of Chemistry and additionally serves on the steering committee for the RSCS Diversity Program. Between 2015 and 2018, he has served as chair of the Memberships and Qualifications Board. He was appointed chair of the Professional Standards Board in 2013. For the first time in the world, he has written a book on ionic liquids along with Peter Wasserschild. And he has bagged a number of awards and honors. To mention a few, 2017 Officer of the Order of British Empire, 2017 Fellow of the City and Guilds Institute, 2016 Royal Society of Again, Royal Society of Chemistry, 175 Faces of the Chemistry. 2012, RSC UCL Thomas Graham Lecturer. Then Imperial College Reactors Award for Excellence in Teaching. 2011, DFT Paul Walden Lecturer. 2010, Honorary Member of the Chemical Society of Ethiopia. 2017, RSC Sir Christopher Ingold Lecturer. And so many. And he is a name in ionic liquids. So with this, I request Professor Walton to deliver his talk.
Good afternoon, good afternoon, everybody, and thank you for that very, very kind invitation. So I shall just share my screen and look for my talk, which I now can't see. Hang on a second. Let me just make sure the talk is open. So I should be able to see it in share screen. Oh, there it is. There we are. Right. Good morning, everyone. So what I'm going to talk about today is not ionic liquids, but about more of the link between chemistry, sustainability and pollution. Being aware that you are a group of school teachers, I felt I wanted to talk about something that you could talk to your pupils about. So here are what we think of as the products of the chemicals industries, pharmaceuticals, the clothes we wear, the dyes that they are coloured with, the products we clean ourselves and our houses with. These are all vital parts of how we live our life today. However, it's clear that very much so, these are also products of the chemicals industries. And so pollution is an increasing concern for people all across the world. Plastics pollution I shall concentrate on quite a bit today. But a great deal, the industrial effluent, but also the products of our own domestic waste. And I'd like to start with this one. And so this is a picture of a river in the north of England in the 1960s, so when I was a child. And it really is my first memories of the impacts of chemical products on the environment. And what you can see in this picture is a foaming river. And so this river has suddenly burst into foam. And what is that foam? Well, what that foam is a build-up of non-biodegradable detergents in the river, which is causing foaming. And the non-biodegradability comes from the particular surfactants that are used in detergents or were used in detergents. And so what we can see from the structures below, I don't know if you can see my pointer, is that we have these linear alkyl benzene sulfonates, and we have these branched alkyl benzene sulfonates. And the linear ones are biodegradable. And so as we wash them into our drains, the local environment can deal with them and biodegrade them. However, these branched alkyl alkyl benzene sulfonates do not biodegrade. They build up in the environment and then they lead to events such as this river foaming. However, this problem did get solved, and this is how it was solved. So the problem was that the target compound was the linear alkyl benzene sulfonates, but the starting material streams had branch chains impurities in it that then got incorporated into the final mix of the products, and so then became the environmental problem. And this was solved by a class of materials called zeolites. And zeolites have another name, which is molecular sieve. And they have these three-dimensional structures in which you get quite large pores and most importantly, of very defined size. And the 5 angstrom zeolites turned out to be highly effective at separating linear C10 to C14 alkanes from the other oil fractions. So that provided a very pure stream of linear alkanes. Those could then be reacted by chlorination to give linear chloroalkanes, or dehydrogenation to give linear alkenes, to give the alkylation agents that then went on to be the detergents. And so the cure to the problem was, as it were, 2 steps away from the synthesis of the detergent itself. It was making sure the starting stream was purely linear, and then what that led to was purely linear, biodegradable detergents, which then took away the problem. And here in the UK, it's now in fact the law that all detergents have to be biodegradable and therefore linear in their structure. So what I wanted to point out there is that, we're not talking about anything new, and we're not talking about things which are problems which are insurmountable. We just need to work our way through and find technologies that provide the solutions that we need. But now I'd like to talk about this event, which is, this woman here is Gro Brundtland, and she chaired the UN World Commission on Environment and Development, which produced this report, Our Common Future. And in this report, she defined for the first time the idea of sustainable development as being development that meets the needs of the present generation without compromising the ability of future generations to meet their own needs. Not a bad one-sentence summary of a 400-page report. So then the idea of sustainable chemistry began to emerge from that concept, which is twofold. So the first part is the implementation of the concept of sustainability in the production and use of chemicals. And so that is thinking about sustainability of the chemicals industries and the chemicals using industries, which I think is a pretty close approximation to what people call green chemistry. And the second part is the application of chemistry and chemical products to enable sustainable development to occur. But as elegant and beautiful as this idea is, we have to be a little bit circumspect because, as Niels Bohr once said, prediction is very difficult, especially if it's about the future. And so let me give you an example of what I mean. So here's a photograph taken in St. Mark's Square in Vatican City in 2005 at night time, and you see the photograph. Here is another photograph taken in 2013, just a few years later, and you see the difference. Let me toggle between the two. So there we are, 2005, 8 years later in 2013, and clearly you can see the difference, and the difference are the screens of our mobile phones. So what are those screens? Well, here is a list of all of the different elements that you can find in a typical smartphone. And I think the first thing you can see is how many of them there are. There's about 30 different elements in our smartphone. Some of them very common, like carbon, some of them extremely rare, as we will see in a moment. But our screen is this material here, indium tin oxide. And indium tin oxide is a remarkable material. It's transparent, so you can use it as a screen, but it's also conducting, which means that you can use it as a touch screen. You can give instructions to your phone through the screen because of indium tin oxide. So in just a few years, indium tin oxide has gone from being a material of, great interest academically, but, not necessarily great use, to being a material that many of us have sitting in our pockets or bags every day. So it's gone from being of very little interest to the general public to being pretty much central to how many of us live our lives. Now, let me show you this slightly unusual periodic table. So this is a periodic table produced by the European Chemical Society, EUCHEMS, for the 2019 International Year of the Periodic Table. And what it's representing is the relative amounts of the different elements. And so the larger the symbol, the more of that element that there is. It's on a logarithmic scale, so twice as big is 10 times as much. And then there's a color coding. And the color coding is green, which is, of course, just plentiful supply. Then there's yellow, which may be some limited availability and maybe future risk to supply. Amber, with a rising threat from increased use, and the most serious threat in the next 100 years is coloured red. So where do we find indium? We find indium in red. And so indium as an element has gone from one that is of academic curiosity to an element that is absolutely vital for how we live our lives in this century. And so if you go back to the beginning of the century, if you're sitting in 2001, no one would have predicted that indium would be vital to our lives. And so therefore, how could they have predicted their use of indium being putting at risk the ability of future generations to meet their needs if they didn't know that future generations were even going to need indium? And so the idea is a little bit more complex than that one sentence might lead us to believe. But of course, that's not surprising. It is, after all, just one sentence. So now, the way in which people look at this is they think of sustainable chemistry, and particularly that second part, as being the application of chemistry and chemical products to achieving these, the Sustainable Development Goals. And I think I used to have to go through them, but I think people are much, much more familiar with them now. There are 17 of them. Some of them are really quite technical. Some of them are more societal. But even those societal ones, gender equality, chemistry has a great deal to offer every single one of these goals. And so we now think of sustainable chemistry as chemistry to enable the Sustainable Development Goals to be achieved. And whilst we're doing that, we need to use less stuff. And particularly, I like this idea from István Horváth of relating our use of material to rate. And so we need to consume nature's resources at a rate that is lower than that at which they can be replenished. And if we do that, they will be replenished. And so we can continue in a sustainable way. We also need to make less waste. And again, relating it to rate, we need to produce waste at a rate which is less than that at which it can be naturally remediated. And so if our ecosystems can deal with the waste that we're generating in a sustainable way, then we have a sustainable chemicals production and use system. So that's what we're trying to achieve. Now, as I said, I'm going to come to plastics, and plastics have really come to the fore in the last few years, partly due to a series of television programs across the world, where we have seen that plastics really are everywhere, and they can have devastating consequences for the environment and for wildlife. And so let me give you an example. So here on this map, you can see a tiny little dot in the middle of the Pacific Ocean, and that's called Henderson Island. And it is about as far away from major urban conurbation as it is possible to get. And yet, The photographs are photographs of its beaches. And you can see that they are strewn with plastics. And indeed, a study in 2017 showed that there were over 37 million items of plastics weighing over 17 tons on Henderson Island's beaches. And that was nearly 350 items per square metre. So plastics really are everywhere. As far away from human habitation as you can possibly think, we find plastics, our waste. But why are they everywhere? Well, they are everywhere in this sense. As I showed you at the beginning, the products that we use. So whether it is the material itself, if you're wearing a polyester fabric, you're wearing a plastic, whether it's a container for things that you have in your house, whether it's a bag, whether it's a water bottle, whether it's plastics are everywhere. And if we look at the pie chart here, what it's showing you is the amount of petrochemical production by mass. So this is everything that comes out of an oil refinery that is not fuel. And what you can see is 80% of what we make is plastics. So it's not surprising plastics are everywhere because we have them everywhere. We use them everywhere. They are central to how we live our lives. And so we have to think about what happens to them. So here is a picture of all of the plastics production that there has ever been. It's in millions of metric tons. And so the primary production is 8,300 million metric tons of plastics have been made. And of those, 2.5 billion metric tons are still in use. And we have to remember that plastics are fantastically durable materials. I did a search around my kitchen, which is where I'm sitting today, and looked for the oldest piece of plastic I could find. And it's the cutlery holder in one of my drawers, and it is over 30 years old. And so plastics are really durable materials, and we want them to be durable. We want them to be able to last long. But of the plastics that aren't still in use, only 600 metric tons have been recycled. That's a tiny, tiny fraction. Most has been discarded, so nearly 5,000 million metric tons have been discarded, and 800 million metric tons have been incinerated. So the energy recovery made, which is, is not the worst thing you can do, but it's not a great use for plastics. Now, if you look at the graph on the right-hand side, what you can see is the projections for our likely use up to 2050 for the next 30 years. And you can see that there is if we carry on as we are, there will be huge, huge, huge increases in the amounts of primary waste generated from plastics. So we need to do something about this. And one of the things I think that this is particularly good for school children is you can talk to them about things that they can do, and that's what I'm about to do. And so we have the 5 R's. And the first is to refuse. There are some things that we use for plastics that we can say, do you know what? I don't want to use those. I am not going to use that product. And I give an example here of helium-filled balloons because they are filled with helium, which is itself a precious material that should not be wasted. And we let them go at some charity event or something like that, and they just distribute themselves across the environment with no control at all, where they suddenly end up here hanging in a tree. There are other things, plastic straws. There are many plastic materials that actually, if we think about it, we don't need them. And so we as individuals can decide, I do not want to use that particular plastic product. But as I've said, plastics are central to how we live our lives, and we can't just stop using plastics. If we stopped using plastics, we would not be able to live the kinds of lives that we do now. So the second is to reduce. Now, some of this has been happening to us, if you like, in that the manufacturers have moved very much away from, again, when I was younger, a month's worth of detergent came in a huge, great box like this. And then when liquid detergent started, it came in a massive, great bottle. And what the manufacturers have spent a lot of time doing over the last decades is making concentrated brands. Now, concentrated brands mean that you get the same amount of material property, the same amount of cleaning power we hear from less material. And of course, less material means you need less packaging. Less packaging means you need less plastics. And so by choosing those concentrated brands, we are reducing our use of plastics. Also have to say, you reduce the weight of the product, and that means that then less fuel is used in transporting the product. So there are other benefits as well. And then in the middle, you can see another example here of where what the manufacturer has very conveniently done for us is tell us how much plastic this refill has. And so not necessarily using the original, buying the original container again and again and again, but using the original container once and using a refill rather than a fresh in the new container, and you greatly reduce the plastics use. And so you can choose a refill rather than buying the original bottle over and over again. And then on the far right, there's another example of one I found. And so here, what they've done is they've even concentrated the cleaning solution down. And what you do is, rather than refilling the original bottle totally, what you do is at home, you refill the bottle with water from the tap, and then you just add the cleaning agents to it. And so an even greater saving in the amount of packaging. So we can reduce our use of plastics by careful thinking about what it is that we buy. The next is to reuse. And of course, again, we've become much more familiar with this. I mean, I think across the world, there is a great movement to stop use of single-use carrier bags. And so people use reusable bags that are strong and sturdy and can be reused again and again and again. And of course, each time you reuse it, we're now quite familiar with seeing people carrying around a bottle of water that is in some container that they're bringing around, but it doesn't necessarily have to be a expensive branded bottle. It can be just refilling a bottle. And so we can reuse, and every time we reuse our plastics, we reduce our consumption of plastics. And now I want to spend a bit of time talking about recycling. And so these symbols are the international symbols showing the different types of plastics that can be recycled, and we can either, in some places, people are asked to recycle these separately. In some places, they are commingled and then separated further on down the line. And so I'll talk to you a little bit about what happens with one of these, which is the first one, which is polyethylene terephthalate, which is most water bottles are made of polyethylene terephthalate. And it's a remarkable material. It's a polyester. It is, when you say polyester, as in polyester cotton, it is polyethylene terephthalate. So it has a huge, huge range of potential uses, and is very much around us all the time. So a really valuable material that can be recycled. But as I say, often plastic waste is commingled, which means that all plastics are put together, which means you have a mixture of different materials. But even our water bottles, and so I said most water bottles are made of PET, yet most water bottle lids and caps are made of either high-density polyethylene or polypropylene. And so these need to be separated. And this is how that happens. And so the first thing that happens when our plastic wastes are collected is they're taken to a sorting centre, and the first sifting is actually by hand. And then, and this is a lovely way of teaching the electromagnetic spectrum. And so, of course, I won't go into it in detail with you, but here's the electromagnetic spectrum. And you can see across the top the various different uses of various different wavelengths. And so X-rays, of course, we take X-rays. Visible light we use to light our homes. Infrared is the radiation that is used for our remote controls for our television. Our mobile phones operate in the microwave, and of course radios operate in the radio wave. But what I'm going to talk to you about now is something that happens in the infrared, and so a nice way of showing the infrared. And so here, what you can see in the top right-hand corner is an infrared sorter. And so what happens is that the plastics have an infrared light shone on them. And what you can see, if you look very carefully, so this red line here, there's your polyethylene terephthalate, that red line there. And then you can see all these strong absorbances here belonging to other types of plastic. And so the absence of this band tells you you've got polyethylene terephthalate, and the sorter uses air streams. It blows the plastics to sort them, and so it can separate the polyethylene terephthalate very successfully from the other polymers by following that band there. And so that gives us our separation of our plastics. I should say that I should have put those slides the other way around. The plastics are cut into chips, which enables that to happen. There is another separation you can do, and again, this is a demonstration you can do in a classroom, which is looking at the density of the different plastics. And so if you cut the plastics up into small chips and get a glass of water, what you'll see is that the PET will float to the bottom because it's more dense than water, and your high density polyethylene and your polypropylene will float on top of the water, and you can see a separation by density. And indeed, that is one of the techniques that's used in these water separators, where the more dense PET sinks to the bottom and the less dense polypropylene and polyethylene float to the top. And you can, of course, demonstrate that in the classroom. Then finally, and here's a little bit of chemistry, perhaps for the later years classes. And so, as I said, PET is a polyester, and we all know that polyester can undergo hydrolysis. Polyester hydrolysis is a typical reaction that we teach. Yet we use it to hold our water bottles. And so there's something going on here, isn't there? Because our water bottles don't dissolve in the water that we put in them. And of course, that is that this reaction needs a catalyst or a promoter for the reaction. And this is what's done in the recycling system, which is called a chemical peel. So they don't attempt to dissolve all of the PET, but because it's often used for applications that require very high levels of hygiene, like being a water bottle, what they do is they do a chemical peel where they take off a very, very fine layer of the PET chemically to reveal a fresh, clean surface underneath. And the way they do that is they start it off by using a sodium hydroxide solution, so strong base in water, and that leads to the disodium terephthalate salt and the ethylene glycol. Ethylene glycol can be used to make PET. And then what they do with that is they then acidify it with sulfuric acid, which takes you back to terephthalic acid, and that all washes away. And I say it can be chemically recycled. And so there's a bit of chemistry in that recycling that you can teach the later years students as well. I'll skip over this slide because I can see the time, but basically this is people who are looking at the ways in which you might chemically recycle all of the PET, are looking at hydrolysis, methanolysis and glycolysis as possible chemical reactions for that. But as I say, I'll skip over that seeing the time. The other thing that you can do is responsible disposal, and that is take your litter home with you, and make sure it's disposed of properly. And another thing that you can do, and it's become a very popular activity here in the UK, is a number of organisations will organise beach cleanups, riverside cleanups. So you go out into the countryside or the seaside, and you actually collect the plastic waste so that it can be disposed of properly. So that's responsible disposal. Now, finally, a little bit more chemistry for the later years students, and that is to replace. And that is to think about which materials we could use to replace the materials that we're currently using. And a lot of people are interested in biomass derived materials. Cellulose, I'm wearing a cotton shirt, and so cellulose is a very durable, flexible material. But also people are interested in what can be made from lignin, for instance, and cellulose lignin composites. And of course, we have a challenge there. And so what we need to do is that, there are some materials that we want that material, and we need to make the currently available materials from renewable resources. Another challenge is to make new materials that match the properties of the currently available materials. So, my water bottle, I don't care that it's made from PET. What I care is that it holds water. And so I would be happy to have it made from a different material. But also, like we saw with the indium tin oxide, we will need to and will make materials that have new properties that currently available materials don't. And so if you think about the replacement of that indium tin oxide, the truth is it is likely to be replaced by a plastic. And so we can think about, can we generate those conducting plastics from renewable materials? And seeing the time, I should jump over these very quickly. And so some of the things that we want to think about, so we want to think about biodegradable materials. We do need to think about that very, very carefully, because not all materials that are thought of as biodegradable biodegrade in the general environment in the way that we think we do. I can just discard this, and in no time at all it will decompose into nothing. Many biodegradable materials have to be composted in industrial composting units in order for the biodegradability to be real. And so that's something that we need to consider. So there is still an important part of that responsible disposal to be considered. I shall jump over this. If you want to find out more about it, I recommend that you look at this report on sustainable plastic use from the Royal Society of Chemistry, where the sustainable plastic use has been broken down into 4 major challenges of understanding the impacts of plastics throughout their life cycles, developing new sustainable plastics, closed loop plastics recycling, and understanding and controlling plastic degradation. And you can find all of that on the RSC website under progressive plastics, or if you're a social media user, hashtag progressive plastics. And so with that, thank you very much. And I think I have a few minutes where I can answer your questions.
Thank you, Professor Welton.
Yeah, very nice presentation.
For the nice presentations. So we have few questions in the chat box.
Okay, so I'll open the chat box.
Yeah, some is asking why there is a need for research on biodegradable detergents in UK. What are the pros and cons of the research?
So in the UK, there isn't. So this is a solved problem. The biodegradable detergent problem was essentially solved technically in the 1960s. And so it moved from being a scientific problem to being a political problem. And indeed, in the early 1970s in the UK and in Europe as a whole, the legislation was introduced that all detergents had to be biodegradable, and they have been ever since.
Another question is, can AI help in visualizing the impact of a new material on sustainable development?
So I think the answer to that is yes. And I have to say, so I'm afraid I'm an old-fashioned stir-it-in-the-pot chemist, and AI is beyond my understanding. But I do have colleagues who work in AI and chemistry, and absolutely AI can help with this in being able to tease out correlations that we can't see, and to be able to predict properties of materials. And I do know that I have colleagues who are working very much on both the design, synthesis and predicting of material properties through AI. So yes, I think it absolutely will provide an answer in the future, but I'm afraid I'm a little bit left behind by that technology.
Another question is there any laws and regulations in international level to minimize the plastic waste in the sea level as well as environment at present context? So
at the moment, no. As far as I'm aware, there's nothing preventing you from legally from dumping your waste. There's a growing interest in it. And one of the things that I'm aware of at the moment is the UN is in the process of setting up a body for, they call it the Science Policy Interface. And so a bit like the IPCC is. So they set up a body which can provide the scientific evidence and advice, which then allows policy to be developed. And I am aware that the UN are at this moment looking into that around chemicals and waste. So soon, I think, is the answer to that one.
Someone is asking about throwing nuclear waste into other planets. Though not a chemical process, can it be a responsible disposal?
Well, I do know the concern that people would have is that, how many failures of rockets are there? If you're going to throw something into space, you have to put it on top of an explosive combination of chemicals. And we know that although the technology is now quite old and reasonably reliable, that every now and again a rocket blows up on a launch pad. And if you're going to put nuclear waste in it, you would need to be very sure that wasn't going to happen.
Another question is, what is the durability of lignocellulosic material?
So it's currently being researched quite heavily. So so as we know, so cellulose is quite durable. This shirt is by no means new, and I expect it to last for some time yet. So it's a very durable material in that regard. Cellulose is biodegradable. Under the right circumstances, it can be biodegraded, and so it has a great controllability then. What we know far less about is the durability and the biodegradability of lignin. And I have seen statements in the literature from, lignin is a biodegradable material through to lignin is a totally unbiodegradable material and everything in between. And so clearly it's complex and it is currently a matter of research.
Someone is asking, is pyrolysis a better way to decompose the polymer material?
Well, I think I think it's a matter of
about the pyrolysis.
Yeah, I think it's a matter of horses for courses, as the saying that we have here in in the UK. I think for some materials, pyrolysis is absolutely the best thing to do. For others, you want to recycle. For others, you want to biodegrade. And I think it's a combination of the use. So is the material being used in a way in which it would just be prohibitively expensive to bring it back together for processing, in which case you want something biodegradable? Is it something that actually we want to last a long, long time and so be highly durable? But then you might have a material that is highly durable but can be recycled, but you might have a material that's highly durable but is not easily recycled, in which case then pyrolysis becomes a much more attractive technique. I think the thing is, we should think about a kind of hierarchy, shouldn't we, of, you know, being able to just reuse it again and again and again, being able to recycle it, you know, and so on, then starting to think about, well, maybe getting chemical recovery from it. And then if I can't get chemical recovery from it, at least I can get calorific recovery and burn it. And so, you know, if we had that kind of idea of a hierarchy of use of plastics, I think that would help us a lot in then determining which plastic gets used in which product, and then what we do with that as consumers when we finish using it, because it's a complex relationship between the producers and the consumers. You know, we both have important roles to play in a sustainable plastics future. And one of the things that requires is that, you know, us as consumers, it is made easy for us to know what we need to do with a particular material for the best, and not, you know, you don't, if you have to have a PhD in chemistry to understand how you recycle your different materials, we're not going to get anywhere. So it needs to be simple for us as consumers, and that relationship with the manufacturers has to be clear.
Another question is, what about feasibility of plastic waste into petrol-like products?
So I think, so that's the pyrolysis argument, isn't it? I mean, so you would take it to some, you know, you probably pyrolyze it down to synthesis gas and then use Fischer-Tropsch kind of catalysis to make useful chemicals out of it.
I repeat, is there any chemical material by which replacement of plastic possible?
Well, yes. I mean, that's the, I'm sorry, I rushed through it quickly at the end, but yes, I think the chemicals from biomass has got huge promise for replacement of many of the materials that we currently use.
Another is for pyrolysis. What he is asking is, in pyrolysis, what about flue gases?
So, I mean, okay, yeah, flue gases can be an issue, and there will certainly need to be some robust flue gas scrubbing technologies whenever you're thinking about pyrolysis. But, you know, those technologies on the whole do exist, and so those problems can be solved.
I think there are no more questions in the chat box.
In that case, thank you very much.
Thank you very much, Professor Welton.
Thank you.
It was a really very informative, wonderful talk. Just chemistry for a cleaner world. And you have very well gave this biomass derived materials. You have enlightened us about the common causes which have to be considered for the sustainable chemistry development. The very good example was the detergent. And one good example you have taken, just that was the Vatican City, which you have shown what it was looking in 2005 and in 2013 with smartphones in each and every hand. So you have told about what are the elements about the smartphone. That is the way how to teach, how to deal. And you have shown about 90 elements. That was very good. That make up everything. And for how long There are few elements which you have shown: indium, tin, and antimony, lead, which we don't have much. So what you have emphasized on the word less for nature's resources. Use less stuff, make less waste. And also from the 5 R's, you have emphasized each and everything. You have clarified what we have to do for the sustainable chemistry, sustainable world. Thank you very much once again, Professor Welton, for this very informative talk. Thank you.
Thank you, and enjoy the rest of your conference.
Thank you.
Bye-bye.
Thank you very much.
Bye.
Bye.
So now we move to the third speaker of this session. He is Dr. Ankush Gupta. Dr. Ankush did his integrated masters in chemistry from IIT Kanpur in 2005. Then obtained a doctoral degree in physical chemistry from Cornell University, US in 2011. Since 2011, he worked in the National Institute of Science, Technology and Development Studies, a CSR institute, New Delhi, as a fellow scientist. Then he worked on an EU-sponsored project on bank filtration as a technology for drinking water supply in the Environmental Engineering Department in IIT Roorkee for 2.5 years. Since May 2015, he is associated with Homi Bhabha Center for Science Education, HBCSC, as a reader. His areas of interest are chemistry education and environmental education. He has been involved with the Chemistry Olympiad program and National Initiative in Undergraduate Science program run by HBCSC. Now I invite Dr. Ankush Gupta for the deliberation. Dr. Ankush.
Thank you, Dr. Rajan. Are you able to hear me clearly?
Yeah, please. You are
okay.
audible.
Okay.
You are audible, sir.
Okay, thank you, sir. Thank you, Dr. Pare. And thanks to all the organizers for giving me this opportunity. What I'm trying to do today is present some of the efforts that we have been doing. Just 1 minute, I'll. Okay. Are you able to see my presentation?
Yeah.
Okay. Okay. Thanks.
It is visible, sir. No.
So, what I'm going to talk about some of the efforts that we are doing at HBCSC to think about relevance of chemistry curricula in the life of students and particularly in the teaching learning process as a whole. And therefore, I would talk about these efforts in the context of chemistry curricula as a whole. As a student, there are many instances when I can recall, I used to struggle or get frustrated about, what the teacher is teaching about. What's the use of all this? Kahin to kaam nahi aane wala hai. And many of the times, whatever chemicals, reactions which we were being taught, I used to imagine that, these are very super speciality elements, super speciality compounds, super speciality materials. And perhaps these must be available in some specialized labs in America, or some distant land where things are far advanced. And I'm sure you can't find them around here. And I must say it has been a big surprise after, long period after my education when I'm trying to see this question a little deeper, is that many of the compounds, many of the elements which we used to study about are right there in our surrounding, right there in nature, right there in the materials we use, right there in many of the products that we are using. And that comes as a surprise, because the moment I realized that the element I'm reading about is right there in front of my eye, my motivation, my interest for that substance increases a lot more. And I think that that kind of a struggle exists for many students. So thinking a little bit more about this struggle, we say that education is for society, education is for progress of society, is for tackling problems. Now we are dealing with a big pandemic, so everyone is looking forward towards scientists as savior, because that scientists are expected to give solutions to the problems of society. Now pandemic has become such a big problem that almost it has brought life of almost everyone to us either a standstill, or it has forced us to change. And that's why all of us are seeing science as a channel to solve this problem. But if you look around, there are several problems. I think today has been a great day in which many speakers, starting from Professor Peter Mahaffey to recently Professor Walton, they have been emphasizing the need for sustainable development and the role chemistry can play in it. And they have been talking about system thinking, that we need to look at what are the channels in which we are creating destruction in environment, and connect it to the chemical reactions and bring those in our classroom, so that our students become more capable of addressing these problems at a later stage in their lives. So here I am trying to show you some examples which are specifically from Indian context, and trying to bring it more closer, because the local context, the more local context is, and the bigger connection a student can see to the discipline, we feel that it will bring a larger motivation, and side by side it serves the real purpose of the subject, that is to serve human beings. Before starting, I must acknowledge my colleagues at HBCSC, Savita Ladge, Swapna Narvekar, Indrani Das Sen, and many others, including all the resource persons, faculty members and scientists from different institutions who have been working with us in different capacities and helping us either develop some of these materials or brainstorm on some of these ideas, so that we are able to share some of this material with you. With that, I want to start with certain situations to give you examples of situations in which there is a desperate need for a better chemical understanding, and perhaps it has missed from the eyes of chemical educators, chemistry educators. So I'm giving one example of a strong acidic compound which is used to ripen apples, mangoes, bananas, and I think large number of fruits that we eat. Including these, the same chemical is also used on several grain crops. And many of the degradation products of this compound have harmful effects on humans and animals. And the unfortunate thing is that we did a recent study about this chemical and its knowledge in Indian context. And we rarely found any groups, research groups or education curricula where this chemical is being discussed. In fact, nowhere in India we found anyone who was even aware of the pH of a solution of this compound. And there is a gross misuse. There is a lot of the way it is, the solution of this compound is prepared in such a, ideally you are supposed to dissolve it in a slightly alkaline solution so that ethene is released, and ethene is supposed to come in contact with the fruit or grain. Where because of lack of knowledge about the proper use of this chemical, most users simply make a solution of it and sometimes just directly spray it on the chemical. And of course, you can imagine what impact it must be having on people's health. And this is a chemical which affects more than 50 crore Indians, according to a crude estimate. And this is used in about at least 1 lakh ton quantity per year in India. And this is a chemical I think none of our textbooks find a place for. Another example, I heard about it in my childhood, but I thought that as time progresses, scientists will find solution to it, and these problems will disappear. But it has been more than 20 years I've had that dream, and I keep coming across newspaper articles which tell about how the market of synthetic milk has increased. And synthetic milk, for your information, is not dried milk. It's a milk made by mixing urea, oil, detergent, starch or other sugars and water, and it can be produced at a price of about 5 rupees per kg. And it's usually mixed with cattle milk, which is supplied to our homes. And the most amazing thing is that the milk samples which contain this synthetic milk often pass the analytical chemistry tests which are done in the labs where these milk samples are tested. I have quite often, I had opportunity to talk to the officers in those labs, the scientists taking care, and I asked them what tests you are doing, and they'll say, we are doing this gel-down nitrogen test, we are doing this lactometer test, and therefore, see, this sample is perfectly fine. And and then you come across this news that such a big racket has been busted. So how is it that we have trained chemists and they are not able to deal with samples that are cheating the analytical chemistry tests which they are doing? Because in none of our education in none of our curricula or our programs and laboratory exercises, we are taught how to deal with samples that can cheat this particular analytical test. I'm giving a parallel example in computer science. I don't know how many of you are aware of not. There is there are specific courses which are designed on hacking. Students are taught about hacking. There are exams when they are given a system and they are taught how to hack it, so that later on, they become capable of making network systems that are hacking proof, or at least they are capable of increasing security of a system which they design in future. And perhaps in chemistry, we don't have any such training in our education. And there are many worse situations like this. Here I want to share one real story, and I think as I read the story, you can understand what's going on there. So it's a day of July 15, 2017. It's a story from Delhi. Two friends, Anil and Deepu, they left the shelter for homeless. That means they were staying in a homeless shelter in Chhatarpur, Delhi. They left their home, the shelter, at 8:30 a.m. so that they can come back early to be their time for their next job as a waiter. And they wanted to earn a little more money. So they were going to a farmhouse and they joined another person who had contacted them, Swan Singh. Swan Singh's son, Jaspal, and his friend Billu. So these are 4 people. They get together and they reach the farmhouse in Ghitorni. They meet the farm manager Niranjan, who showed them the task. And they were told that it's a rainwater harvesting job. And they were supposed to clean the rainwater sewer. It's a simple cleaning job. No one expects that it requires a technical expertise. And therefore you can usually call unskilled labor. Most of them are quite uneducated. So without any preparation, Anil went into the sewer. As soon as he entered, he fell down. Watching this, Billu went down to take him out. He did not come out. To join his friends and to save them, Deepu also went into the sewer. When Jaspal, who was Swan Singh's son, heard no voices coming from the sewer for a few minutes, he was a little worried and he called his father Swan Singh. He did not go into the sewer himself. In 15 minutes, Swan Singh reached the farmhouse. To save the first 3, Swan Singh tied a rope around his waist and went down. He also started becoming unconscious by the toxic gas. And finally, Jaspal tried to save his father, but he also fell down in the sewer unconscious. And 4 of the 5 men died on the spot. And this is a grim situation in which even when you call for help, the people around you don't know how to help because no one knows what's happening. It seems like a mysterious gas. And for 10 years, I have been observing the same story repeats every other day. Or if you are following Indian newspapers, every 3rd or 4th day, you can get a report where you see at least 2, 3, 4, 5 people who have died out of the toxic gas coming from sewers. And so far, there have been a lot of discussions. There are political debates about how much should be the compensation, who is to blame. But there has never been the thought that we need this is a scientific problem. We need scientific understanding. And this is a matter, sewage and sanitation, this is related to all of our lives. They are not related to lives of some specialized people, but in some parts of the corner of the world. So the chemistry of sanitation and drainage, which is a related to everyone's life should need to be a part of basic science education, or at least some level of science outreach. And the other thing is also we need teachers who have this understanding, who can teach this to at least certain fraction of the population, so that people know what to do, how to handle this situation. And of course, a wishful thinking is that we have scientific solutions so that such situations at least don't occur at all. This is something related to what has been already said, but I goes one step further. Some of you may already be knowing that India and many other South Asian countries are home place where most of the electronic waste from the world arrives at. And this, a lot of this electronic waste, including many of the toxic laboratory waste, are dumped at sites where they are handled by people who have no education. You know, these are people who are absolutely uneducated people, and they do their best, they hammer it, they grind it, they try to clearing concepts really means going to the reality. You know, what is the reality that you're trying to describe? You know, what assumptions you made to describe that reality? And then based on these assumptions, what are the components in which you are trying to describe that reality? And then only a learner can truly understand the concepts. We are all teachers, and I'm sure if we reflect on our journey in understanding those concepts, all of us have gone through this journey. It requires little reflection. Now, what we at HBCSC have been attempting, we are trying to create examples for this modeling process as guiding programs. You know, we are trying to create opportunities in which learners, whether be a teacher or a student, can start engaging with this modeling process, because then only we feel empowered to be able to understand and generate concepts whenever we see. Here I am taking an example of a problem which we designed in 2016. It's describing one aspect of a sewage system, and that is relating to the sulfate to hydrogen sulfide conversion. Hydrogen sulfide is one of the poisonous gases which is responsible for death of many waste workers. And this chemistry, let me say, is not developed by us. It has been developed it's been known in literature. It is more than 50-year-old chemistry, but it is buried in textbooks. It's not taught in classroom. However, to simplify it for the language which is understandable by schools and college students, what we have to do is we have to identify simple and major chemical species and write approximate chemical equations. And let me emphasize here that writing the approximate chemical equation for a system is a very important, very much needed process, and it's not so easy process. And because of this, we never ever try to teach this in our chemistry curriculum. And I'm trying to emphasize this strongly, that if we have to empower our students to become problem solvers for tomorrow, to become innovators for tomorrow, we have to get into this process. And the process is, you look at the system, you identify its component. You know, here we are saying that, okay, we are looking at sulfur, but sulfate is always interacting with oxygen and nitrate because these are all oxidizers. So we identify the important species. We identify what it is reacting with. And for organic matter, you know, organic matter is a complex matter. It has protein, carbohydrates, and all. We have simply represented it as a simplified CH2O just for writing the equation, so that at least we can proceed. Otherwise, we'll say, okay, it's such a complex reaction, I don't know how to write this stoichiometry. This is a very approximate stoichiometry, but it helps us to proceed and make many meaningful predictions. Next, we have to make certain assumptions, simplifying assumptions. You know, okay, is the pH variable or pH static through the reaction? We have to have some estimate about what are the typical concentrations of sulfate in the sewage system, and the number doesn't vary by order of magnitude. So therefore, we take a certain number. Okay, we make certain assumption that the gases diffusion. Let's assume for a while that gases are not leaving the system; they are remaining in the solution phase. So when we make these assumptions, we reach to a stage that we can make some estimation, okay, how much must be the H2S concentration in the system. And then if you look at the septic tank itself, you know, septic tank, it's not a homogeneous reaction mixture. I mean, most of the time when we look at the reactions, we think of that all reaction mixtures are homogeneous reaction systems. Septic tanks have different concentration of different species in different parts of it. And even in the air space above it, gases, we remember that gases diffuse into each other, but the diffusion process has its own time scale. And therefore, if you look at different parts of septic tanks, it has different concentrations of toxic gases. And this is a very important part which is often ignored in designs of septic tanks. So if we have to say that, okay, chemistry can solve the problem, can we give you better design, give society better designs of septic tanks or sewer, we have to really start thinking about that the gas above the sewage is not a homogeneous mixture. It has its own spatial variation. So how are we, are our students who have done high secondary school or undergraduate, are they capable of predicting this spatial variation? Let me tell you, yes. We have given this problem to 12th class students, and a large number of students are capable of solving it. So therefore, we are trying to give a proof also that this is not an impossible task to do. Here we have made an attempt about how do we start engaging with the problem of electronic waste. So we took some research papers which are trying, not from India. We have very few work going on this in India, but globally, how do you start understanding, how do you start separating different metals from a circuit board? So, and we follow the simple, the qualitative analysis process, which is taught in almost every school and college, which involves separating metals from different, as you move from group 1 to group 2 to group 3. And we show that if you simply follow this process, we can achieve effective separation of many of the metallic components of this this complex mixture. And we are trying to develop concepts which can be taken forward to at least start engaging with this problem. Similarly, I am coming to this problem of modeling milk. So milk is considered to be a complete food for infant, or whether it's of mammals or of human beings. Therefore, it has almost all the nutrients that human beings need. It has carbohydrates, proteins, fats, minerals, vitamins, water, many things which we have perhaps many enzymes. So how do you start understanding this system? And there are many ways, many different ways in which you can model milk. A nutritionist would model it in perhaps a different way. But if we are trying to address this problem of analytical tests, how do you tackle this problem of milk samples being cheated? We have to look at the analytical test. So here we look at the first test which is done for milk analysis is the gel nitrogen test. So we have to start thinking, okay, what are the species in milk which will go through gel test, and what these adulterants do. The people who are samples, they the same analysis. Here we go through analysis which involves spectrophotometric analysis also, and we show the way we design our examination questions. We have to be explicit about assumptions that are made to make the model. We have to be explicit about evidence or observations that are available to support the concept. So can we take this whole process to our textbook? If I say this, I'm sure many of you will say this is a tall order. This is a very difficult, challenging task. It requires a large number of people. It requires a lot of effort. That's quite true, But I want to give you something that is not impossible. Who are working on it, and they're trying to develop some material. Professor Mahaffey in the morning gave some example, and many other research groups are working on it. But before I move on to the current examples, I want to give you an example of a textbook from 1847, more than 170 years ago. This is a textbook on, the title says it's a textbook on natural philosophy, but at that time, a lot of what was taught in natural philosophy at that time is what we call a science. And this was written by Professor John William Draper. Professor Draper was a physician, was a medical doctor, and eventually he ended up becoming a professor of chemistry. And I think there is a merit in it. I want to read through some sections of this textbook to show how he described a particular idea in the textbook. So this is the starting chapter of the textbook. Here I read through it. Material substances present themselves to us under 3 different conditions. Some have their parts so strongly attached to each other that they resist intrusion of external bodies. and can retain any shape that may be given to them. These constitute the group of solids. So in contrast, if you think of for today's book, the book will start that matter is of three types: solids, liquids, and gases. Solids are those which retain their shape. They have a well-defined shape. It requires force to deform them. Okay, just think the way the content matter is presented. In this case, first description is given. Okay, and the technical word or a concept is introduced later on. Then he goes on to describe that, how do you start describing matter? Because it's an essential part of what we call today's chemistry. Okay, so he's saying that all matter exhibit certain properties. These are, first he wants to say that first we should look at distinctive properties and then essential. To describe what he's saying, let me read the next paragraph. There is a certain bright white metal passing under the name of potassium. The distinctive character of which is that when thrown on the surface of water, it gives rise to a violent reaction, a beautiful violet colored flaming ball. A piece of lead, which to external appearance is not unlike potassium when brought in contact with water, exhibits no such thing. So what he is trying to say is that there are two pieces of metal. One is both look the same, but one, when you throw in water, it produces a violent reaction with a violet flame. I think the whole learning process becomes more meaningful and more fun. So I'm trying to make this appeal, and we are trying to make this some modules, some little materials. Please keep our website for different topics. And any of you have some ideas, we encourage you also to produce such material. History and philosophy of science can provide one example, and then there are many other channels which other researchers are trying. So please check out that, and we can discuss this more.
There are no more questions. So I just extend a warm thanks to Dr. Ankush for very informative talk. Actually, we started today from Dr. Mahavi, and he also emphasized on curriculum modification. We have to revive the curriculum. We have to design it. And Dr. Biswajit again promoted this, extended further. And at the last, Dr. Ankush has very well supported the relevance for this curriculum designing, taking simple public examples, so examples from the society. He has very well taken the example for that sewer cleaning. Why people die? This is the daily news. We read it. So if people are aware why this is happening, so we won't have these type of incidents anymore. This is the pandemic. Everyone is using sanitizer. He has touched about the chemistry of sanitization and drainage. That is very important nowadays, at least about the sanitizers. I think chemistry, this is really, really needed, because daily we read about using this sanitizer, this happens, that happens. So many incidents are taking place. You have really given full support, full relevance for this curriculum designing, and from the junior level, how students must be taught. They must be attracted towards this chemistry. They have to answer what they are seeing around. So they must know why it is happening instead of just going through textbook. So thank you, Dr. Ankush, once again for this.
Thank you. Thank you very much.
Thank you.
Thank you.
So over to Dr. Premmohan Mishra.
Thank you, madam.
Good. It was good.
Thank you. You have very nicely conducted the session. And the whole day you have devoted for that. We are much thankful to you. As I announced earlier, if there is any presentation, I would like to take that, and after some time we should have AGM, no?
Sir, I'm unmuting all. I'm removing the force unmute thing. Now they can unmute themselves and
raise hands if they want to present paper.
Participants, you are requested to raise your hands if you have wish to present your paper. Sir, Govind Prasad, sir is going.
Yes, sir. I am Kondarpa. Can I start my presentation, sir?
Now you can share your presentation.
Yes, sir. Is it visible? Hello.
It is visible, sir. Please continue. Who is presenting? Please say your name and then.
Yes. Good evening, everyone. Myself, Kondarpa Fukan from PG Department of Chemistry, Henry Girls College, Guwahati. So I am going to present my work on the title Waste Polystyrene Composites with Betel Nut Fiber. I'm going to actually share my experiences, my findings in a research student research project that was done in our department. Introduction. The fiber reinforced polymers are significant because of their widespread applications. Betel nut fibers are easily available, biodegradable, and eco-friendly. Thermocol is a major component of wastage and environmental pollution. The major component of thermocol, or styrofoam sometimes called, is polystyrene, which can be used as a matrix for fiber reinforced polymers. At the same time, natural dyes have potential uses in composites. On the basis of these things, I have the objectives to fabricate composites of was thermocol, betel fiber, and red dye from the sendur plant called Bixa aureliana seeds, and to study the mechanical properties of the composites that we have prepared. As seen in the graphical abstract, I have shown this. In the experimental section, firstly, we have extracted the betel nut fibers in a mechanical way by hand method, and we have treated the fibers with alkali, that is sodium hydroxide. And in the second step, we have extracted the natural dyes from the seeds of this plant, namely Bixa aureliana plant, which is commonly known as sendur plant here in Assam. And then we have followed this aqueous extraction method for extracting the dye, I have shown in this diagram. And in the third step, we have prepared the matrix, polymer matrix, on which we are trying to reinforce it. We have dissolved the thermocol that was available in the college campus, which were thrown out, and dissolved in acetone to get a slurry in a suitable composition. And at last, after preparing all the three components one by one, we have fabricated the composites using a hydraulic-based compression molding technique with a maximum load of 35 kilonewton and a maximum temperature of 300 degrees Celsius. We have prepared the sheets of composites in the plate form using a mold of the dimension 15 centimeter by 15 centimeter by 2 mm. And this is the machine that we have used in our laboratory. And this is the mold we have used. And these are some of the products of the composites in 2 mm thick plates. Okay. And this table summarizes the different composites that we have prepared using different amount of the thermocol, that is the polymer matrix, fiber, and dye. And as per the table, we have seen that maximum 3 gram of thermocol can be dissolved in acetone to get a suitable slurry to prepare the composites. And we have used 2 different types of fibers, different types in the sense we have treated, alkali treated and alkali untreated. Untreated fibers and treated fibers. We have prepared 7 samples, and in the last samples we have tried to red dye the composites using this natural dye in the proportions of 0.5 milligram and 1 milligram. And in the characterization section, we try to characterize the prepared composites for checking the binding, whether the fibers were intimately binded with the matrix or not. And in the characterization section, we have first taken the IR of the samples. I have showing here only two IR. And as per the analysis of the IR, it is seen that most of the peaks that are responsible in the polystyrene, actually polystyrene is the main component in styrofoam or thermocol, polystyrene peaks, and the dye as well as the cellulosic fibers, where we have seen hydroxyl stretching peak at 3694 in the non-treated undyed composite, and at 3286 in the dyed composite, that is shown as B here. And most importantly, we have seen the stretching frequency of the carbonyl in Bixin, for Bixin at 1680 per cm, which Bixin is the main component of the red dye. That is available in the references. And secondly, for the conjugated carbon-carbon double bond in Bixin, we have found it at 1024 per cm. And in the second characterization, we have taken the same monographs of different samples. And first sample, that is A, with 5 gram of the fiber, shows numerous voids with fiber agglomeration and low mechanical strength. And we have increased the amount of the fiber to 7 gram, which shows uniform dispersion of the matrix with less amount of voids and increased mechanical strength, which was manifested in the mechanical strength study section. And in the third SEM, third SEM is for the dyed, with 1 milligram of the dye. With 1 milligram of the dye, it is seen that the fibers
go to result and discuss
and pull out. And in last, mechanical strength done in terms of flexural strength, impact study, and tensile strength. In this case also, we have seen that in summary we can say that the mechanical strength increased in the increase in the amount of fiber. And in conclusion, we can say that betel nut fiber could be successfully used as reinforcing fibers with waste thermocol. It can be a way of conversion of waste thermocol to wealth. This kind of work can create awareness among students community towards reuse of wastage. Actually, I can say that this is a part of our students research project that was done in our college with a funding from our research cell of this college. Again, the betel nut fiber reinforced composites treated for its tensile strength, flexural strength as per the ASTM standards. And it also establishes the application of natural plant-based dyes in polymer composites. This research will keep the door open for extensive work in waste polymering material for reinforcing the natural fibers and natural dyes.
Thank you.
Okay, sir. Providing the financial assistance under the TESOL-led student research project. Okay. I also want to acknowledge the CPED Guwahati for providing facilities for mechanical strength determination. And these are some of the references that I have followed during this work.
Thank you, sir.
Thank you.
Now, may I invite Dr. Amar Srivastav ji?
Yes, sir. Yes.
Please.
Am I audible, sir?
Yeah, you are audible.
Okay. Is the screen visible?
Yes, it is visible now.
The today's presentation is Understanding Metal Carbonyls through Vibrational Spectroscopy. In fact, this presentation has been made for MSc students or the students who are preparing for NET examinations. Metal carbonyls are transition metal complexes with carbon monoxide. Carbon monoxide is an excellent sigma donor pi acceptor ligand. The oxidation state of metal in metal carbonyls is normally 0. It may be low positive or low negative in certain cases. Although it is considered that CO is not a very strong Lewis base, but due to its very good pi acceptance, it is considered to be a very good ligand. The effective atomic number rule, or which we call as 18 electron rule, is observed in most of the cases, and all metal carbonyls are diamagnetic except VCO6 and a few more examples. The CO molecule can act as terminal CO group when it is attached to one metal. It is a doubly bridging CO group when it is attached to two metals, or a triply bridging CO group when it is attached to three metals. The speciality in metal carbonyls is due to its special bonding mechanism. The lone pair which are present at the carbon of the CO molecule is donated to the vacant hybrid orbital of the metal to form MC sigma bond. At the same time, the metal back donates its electron density to the vacant anti-bonding molecular orbital of CO molecule to form a pi bond. Now, these both bonding sigma and pi, they occur simultaneously and they reinforce each other. Now, due to this, the metal carbon bond order increases from 1 to between 1 and 2, and there is a decrease, corresponding decrease in the bond order of CO from 3 to 2 and 3. Now, this information, the vibrational spectroscopy provides many information such as structural diagnosis of the molecule, presence of charge, nature of ligand, nature of product, molecular symmetry, force constant, etc. These can be studied using vibrational spectroscopy. So I'll be taking one by one. Whether the CO group is terminal or bridging, this can be decided by the stretching frequency. I will take Mn2CO10, which has all the bands, CO bands, which are in terminal range. It means that all the CO groups are terminal, hence it has a non-bridged structure as shown in the diagram. But in Fe2CO9, there is one band at 1828, which is in the doubly bridging CO group. Now, this indicates that in this molecule, both terminal as well as doubly bridging CO groups are present, hence it has a bridged structure. The stretching frequency increases if the metal has positive charge due to decrease in back bonding, and similarly, if the metal has negative charge, obviously the stretching frequency will decrease. Larger is the amount of positive charge, higher will be the stretching frequency, and reverse is also true for the negative charges. So we can find out whether the metal is having a positive charge or a negative charge. Similarly, if we perform a reaction, the stretching frequency, whether the liquid better pi acceptor than or a poor pi acceptor. Stretching frequency decreases, then ligand is a pi acceptor, and if the stretching frequency increases, then ligand is a better pi acceptor. As we can see that NO is a better pi acceptor than CO, while other ligands are poor pi acceptors. Similarly, we can find out
yourself, sir.
Okay, sir.
All should unmute. Mute.
Others who are not presenting, please unmute.
We can also find out the nature of the product. The nature of the product can be determined by the number and position of the CO bands. For example, if we have di-substituted product, there can be two isomers. One is cis and the other is trans. If we are getting 4 bands, then the molecule will be cis isomer having C2V symmetry. And if it is trans, then we are going to get only one band due to D4H symmetry. Now, this table shows the as soon as the CO are replaced by ligands, the symmetry of the molecule changes, and therefore the number of IR active modes also changes, and we get different number of bands. Similarly, we can guess the molecular symmetry from the vibrational spectra. For example, in case of FeCO5, it can have two structures. One is trigonal bipyramidal and the other is square pyramidal. The IR and Raman spectra have confirmed that it has trigonal bipyramidal symmetry. The carbon-13 NMR is used, it is not useful because of the fluxional nature of the molecule. Force constant calculations, they can be done using Cotton-Krenzel equation, and the vibrational mode assignments can also be made. But since these require research data avoiding this, thank you so much, sir. Thank you all.
Thank you, sir. Very good. Dr. Archana Singh.
Yes, sir. Good evening, sir.
Yeah. If you are ready, we'll start.
Yes, sir.
Thank you, Amarji.
Just
Very good presentation. Garima Nagaraj is there? Garima Nagaraj,
Yes, sir, I'm here.
be ready.
Yes, sir.
Are you going to present paper?
Is it pretty visible, sir?
No, not.
Hello.
Yeah, not visible.
I have shared. Just a moment, sir. Just a moment.
I request the previous participant to please stop your screen sharing.
Now, sir.
Now it's, your screen is visible, Ashra ma'am. You can start
Okay.
your presentation.
Archana ji, please start. Garima, you ready?
Yes, sir. Yes, sir, I'm ready.
You start presenting paper.
Yes, sir.
Till Archana ji preparing for that. Archana, what happened? Let Garima present his paper and then.
Hello, hello.
Yeah.
Sir. Sir, am I on topic? You of sono have attracted the vast potential in the field of electronics. It's having synthesis. Of 0 degree to 40 degrees centigrade, whereas
Your screen not visible, Archana ji.
to sensitivity for and I have considered gray and needle shaped crystals of antimony acid synthesized solid state thermal reaction technique, and it's I observed this dual electric trait of SBI studied in the visible region which exhibits maximum of green light as compared to red, yellow, and light. Optical found a range of 1.5 electron volt in the semiconductor material. Hello, sir. Hello, sir.
Archana has completed. Then Garima should. Yeah, you have completed your presentation.
Yes, sir. Thank you so much, sir. Thank you so much.
Okay, thank you. Garima, please.
Yes, sir. Yes, sir. I'm sharing. Sir, sir, is it visible?
Yeah.
The title of my research work is Synthesis and Characterization of BMZ Nanocomposite Photocatalyst for Degradation of Methylene Blue Dye under Visible Light Irradiation. The growth of the chemical, textile and dye industries over recent years has led to increasing level of water pollution. Organic dyes are the major pollutants, hence various photocatalysts have been developed. Some of them are titanium dioxide, zinc oxide, ferric oxide, ZNS, etc. Bismuth containing complexes, oxides are gaining more attention due to their cost effectiveness and widespread availability. To date, bismuth containing semiconductor photocatalysts mainly include bismuth molybdenum oxide, bismuth vanadate, bismuth subcarbonate, bismuth oxychloride and bromide, etc. Bismuth molybdenum oxide, a typically layered oxide, possesses a suitable band gap controllable morphology and excellent photocatalytic activity for the degradation of organic dyes. However, its photocatalytic activity is still limited. To improve its photocatalytic performance, different modifications have been attempted. Here, bismuth molybdenum oxide is coupled with zinc oxide, which is believed to be promising photocatalytic material because of its stability, non-toxicity and low cost. In present work, we have synthesized BMZ nanocomposite photocatalyst by co-precipitation method, and methylene blue dye was selected as model contaminant due to its recalcitrant nature. This is the schematic diagram of synthesis of BMZ nanocomposite, and this is a schematic diagram of photoreactor design. Now, adsorption and photocatalytic experiment. These experiments are performed in a slurry type batch reactor having double walled Pyrex spacer. And the percentage of photo degradation was calculated by using the given formula. Characterization of S-prepared photocatalyst was carried out using various techniques such as XRD, FSM, EDX, spectroscopy analysis. XRD measurements are carried out to determine average crystallite size of particle. Surface morphology and chemical compositional analysis were carried out using FSM and EDX. Here is the XRD pattern of S-prepared BMZ nanocomposite photocatalyst. And it is calculated by Debye-Scherrer formula, and the calculated average crystallite size is 28 nanometer. And these are the FSM images. This shows the smooth surface of particle, and the particle are in shape of flag. EDX studies reveal the characteristic peaks of bismuth, molybdenum and zinc elements, which shows the purity of the compound. And at last, the results showed that BMZ composite shows high photocatalytic activity as compared to pure bismuth molybdenum oxide and pure zinc oxide photocatalyst. Thank you, sir. Thank you. Thank you, sir. I have completed.
Okay. Yeah, fine. Mishra ji, you are not audible.
Yeah, Mishra sir has muted himself. So, Govind Prasad, sir, you wish to present your presentation?
Yes, sir. Yes, sir.
Yeah, start with your presentation, sir.
Yeah, start.
Is it visible, sir? Sir?
Till now, it is not visible, sir.
Someone is sharing. Sir. Someone is already sharing screen.
Who is sharing?
Govind Prasad, sir, you can share your screen. No one is sharing his or her screen right now. Yeah, your screen is visible.
Visible, sir? Is it visible, sir?
Sir, it is visible. Please go ahead.
Myself, Govinda Prasad Chutia, Research Scholar, Department of Chemistry, Andy Girls College. I am going to talk about utilization of biomass-derived heterogeneous catalyst for production of biodiesel. Now, the biodiesel is a potential replacement for petroleum-based diesel because of its renewable and eco-friendly nature, and it can be prepared from vegetable oil or animal fats by transesterification reaction using acid or base as a catalyst. Both homogeneous and heterogeneous catalyst transesterification reaction are used for production, but use of heterogeneous or solid-based catalyst for production has gained more attention as they are neither consumed nor dissolved in the reaction mixture, which made it easier to be separated from the product. Moreover, the recovered catalyst can be reusable for several times in the reaction, hence reducing the catalyst consumption as well as provide the better quality product. However, in view of cost and efficiency, bio-based heterogeneous green catalyst derived from the natural resources such as biomass gain more attention. Catalysts generated from the various bio-wastes such as waste cells, animal bones, and the biomass as derived from natural resources has been utilized. Now, the waste cells mainly composed of calcium carbonate with trace amounts of organic substance in water. Upon high temperature combustion, waste cells form metal oxide, which is a highly active base catalyst for the biodiesel production. Now, the activated carbon-based catalysts provide high surface area with high porous in nature. Due to the high number of active sites in activated carbon, it provides sufficient absorption sites for reaction to take place. As a result, the overall performance of the reaction significantly increases. Among the various methods, the pyrolysis and hydrothermal carbonization are the widely used to prepare a biomass-based heterogeneous catalyst for the production of biodiesel. The texture and the surface morphology or the surface functional groups can be modified by employing physical or chemical activation using the best suited activating agents such as potassium hydroxide, sodium hydroxide, phosphoric acid, etc. The heterogeneous catalysts from biomass have several advantages. It is renewable in nature, non-toxic, reusable, shows high catalytic activity and stability in both acidic and basic conditions. The catalyst generated from bio-waste and biomass as from natural resources provides a greener synthetic route to biodiesel. In conclusion, it is clearly visible that renewable energy and resources are the most efficient and effective potential solution to current environmental problems such as acid precipitation, stratospheric ozone depletion, and the greenhouse gas emission. Biodiesel is one of the suitable candidates among them. The consumption of biomass as the source of catalyst formation may reduce the associated cost per commercially available solid catalyst, as well as it provides new applications and utilization for the biomass and biowastes. Thank you, sir.
Thank you very much. Saniji, any more is present here? Nisha Garg is ready to present.
Yes, sir, I'm ready.
Please start.
Thank you so much, sir, for giving me opportunity to present over there. Yes, hello. Is it visible, sir?
Yeah.
Yeah, yeah. Thank you, sir.
Good.
So, my topic is the interaction of spike protein of coronavirus with flavonoid of Clitoria ternata. At present in India, lots of death and positive cases are here, and Clitoria ternata is a rich source of a specific class of flavonoid, which can block attachment and entry of viruses into cells, interfere with various stage of viral replication, process to prevent the release of viruses to infect other cells. Coronaviruses are extremely fastidious and grow only in the differentiated respiratory epithelial cell. So we need a drug which directly affects the respiratory tract, and the extract of the Clitoria ternata has these characteristics. CT is an important twig hub as commonly found all over the India. एक मिनट सर, ये is it? हनी इसको आगे कर बेटा. The popular use of CT in traditional medicine has stimulated research to illustrate the pharmacological activity of the extract obtained from the various CT tissues. Here, root is the most important part of this plant because it has a pungent smell, is a bitter in taste, and is credited with cooling, laxative, diuretic, anti-helmintic, and anti-inflammatory properties. Research suggested that its extract shows antipyretic, analgesic, and larvicidal, insecticidal, antimicrobial, anxiolytic, and antidepressant also. Anti-asthmatic and bronchitis property. It plays a vital role to overcome respiratory infection, whooping cough, goiter, and epilepsy. Its extract, approximate 2-3 gram, is administered with honey and ghee. Seed. The seed Clitoria ternata is combination with ginger powder used to digestive disorder due to the purgative nature, cathartic and the laxative action. These seeds are also prescribed in cough arthritis. Now analysis shows that the root, seeds and leaf flowers are contain lots of flavonoids and the gamma aminobutyric acid, histidine, glutamic acid and so on. Now, most important part of this theory is that how COVID-19 binds to human cell. COVID-19 is a cause of pandemic disease. The first step in viral entry is the binding of the viral trimeric spike protein to the human receptor, that is enzyme, angiotensin converting enzyme. Yan et al. Also present the structure of human ACE2 in complex with membrane protein. The structure provides the basis for the development of the therapeutic targeting the crucial interaction. The COVID-19 spike protein containing the receptor binding region was used as an immobilized target. The peptide identified in this study are useful reagents for detection of COVID-19. Among all the structural proteins of COVID-19, spike protein is the main antigenic component that is responsible for inducing host immune response. The chemical compound present in CT include various triterpenoids and flavonoids. And flavonoids play a vital role. Antiviral activity was the minimum concentration of extract, about approximate 0.5 to 1 gram required to completely inhibit the cytopathic effect. Just a minute, sir.
Please
yes. Yes. Here are the plant which is grown by my at home, also in my college also. The plant roots, plant seeds, and the flowers of these plants, and the pod which contains seeds like a butter pea, and the spike protein structure. Now, as you seen here, the structure of COVID-19 in which the interaction with the myricetin, the flavonoid present in the roots and the flowers, that is myricetin, delphinidine, and the quercetin also, and the most abundant flavonoid which present in this blue pea, that is clitorin, is also affect the COVID-19 spike protein and diminish it. And yes, just a minute, sir. Result and discussion shows that the reported inhibitory effect of medicinal plant, that is Clitoria ternata extract on replication of several viruses. Studies in the past and recent literature suggest that a variety of natural products isolated from the plant inhibit viruses both in vivo and in vitro. Very less concentration of the extract is required to completely inhibit the viral cytopathic effect. The present study shows that the effect of individual part in an inhibiting viral reverse transcription also. An intriguing observation is the presence of antiviral activity, a wide variety of phytochemicals such as alkaloid, flavonoids, glucoside, and polyphenol also. Present study have utilized either water-soluble or alcoholic extract of medicinal plant, and limited efforts have been directed towards the identification. Now, conclusion with review literature is that the extract shows a diverse range of pharmacological properties. Many of these studies are preliminary and require more thorough investigation. In many instances, the authors have attributed the extract activities to the presence of flavonoids and the anthocyanins. However, the attempt to isolate the immunosuppressive property may contribute, as could the abundance of the dalphanidine. CT has been widely used in the traditional medicine, particularly as a supplement to enhance the cognitive functions and alleviate the symptoms of numerous ailments, including fever, inflammation, pain, and diabetes. Emerging viral infections associated with the pox viruses and severe acute respiratory syndrome virus were strongly inhibited by various plant extracts. A number of plants previously shown to possess broad spectrum antiviral effect could be screened for newly emerging resistant viral strains. More recent studies have focused on the direct CT extract on the glycemic response and antioxidant capacity in humans. So it is anti-diabetic also. In an antibiotic study, oral administration of CT methanolic root, not methanolic, that is water extract, root extract significantly reduce the body temperature also, and of Vistara rate. It is, but now as I presented on 20 May, over there the Brajesh Parisar and suggested me to this study and this research should be patented. So I got the patent registered also, and I applied as a preclinical trial, as a research and development, as a guided by my by MPCST. PC Sharma sir, that I have to apply it on a patient near and dear by. So approximately 50 to 60 patients of different types of disease caused or faced different type disease, they are cured within 2-3 days, and there is no side effect of this also. So lot differences are there also. So thank you so much, sir, to give me the opportunity to present over there. Thank you so much, sir Pare sir, who guided me well to patent it, and I am patented it also. Thank you, sir. Thank you.
Thank you. Thank you very much. Shashibala is present. Shashibala is present.
Yes, sir, present.
Yeah. Please start. And Shyam, please. Shyamji, remain ready. Please be ready. I think we have only 2 presenters, no? Ujma. Yes, wait for some time.
Sir, I think Dr. Shyam is there, so I will present after Dr. Shyam.
This is Shyam.
Yeah, it's there. His screen is sharing.
Okay, no.
Yeah.
Shyambi, go ahead, please. Hurry up. Mr. Shyam, please. You are not audible. Shyam, not presenting, please. Others should come, I hope. Hello, Shyamji. I'm not getting your sound.
Shyam, sir, we can't hear you. Sir, he is unmuted, but we are not able to hear him.
Yeah, we are not getting his sound. Okay, we can record. We have seen the presentation, no problem. Go ahead. Shyamji, you can stop screen sharing. We have seen your presentation, no problem. It will be recorded. And give chance to other. Yes, please. Dr. Shashiwala is present. And Ujma Praveen, please.
Yes, sir. Please, just a
Who
minute.
is ready?
I'm also ready, sir.
Yeah. One by one present, please. Shashiwala is presenting?
Yes, sir. Just
Yeah.
give me 1 minute, please.
Okay, no problem. Hurry up.
I'm searching actually my document in mobile.
Then give chance to Ujma Praveen. No problem.
Okay, sir. No issue, sir.
Ujma, you are ready? Dr. Ujma, are you ready?
Yes, I'm ready, sir.
Yeah, then start. Let Shashiwala search for his document.
Sir, am I audible?
Yeah, you're audible. And
My
visible both.
presentation is visible?
Yeah.
Your screen present is visible. You are clearly audible too.
Okay. Good evening to all of you. Myself, Dr. Uzma Parveen from Aurangabad, Maharashtra. I'm going to present a small piece of my work entitled Determination of Tannins in Tea and Coffee Samples. Tannins represent a wide range of naturally occurring compounds that can be found in fruits, dry extract of red wine, tea, coffee, and some non-edible plants also. The antioxidant and antimicrobial activities of tannins are well documented. They are also used as antiseptic and astringents. Tannins are water-soluble polyphenols actually. The aim of this study was to give a comparative overview on the amount of tannins present in the various tea and coffee samples. A simple and complexometric method is used to determine tannins. As tea and coffee are the most widely consumed beverages in the world, so we should know the percentage of tannins present in it. An excessive tannin causes adverse effects on human health, like interference in the absorption of calcium in the body. So for present study, I have taken 7 samples, out of which 4 samples are black tea samples, and 2 are coffee samples, and 1 is green tea sample. These are the findings of my research. So this is the sample 1, which contains 12.8% of tannin, and it is also a black tea sample, second one, of which contained 14.2% of tannin, and black tea sample third also contained 11.8 tannin, and black tea sample 4 contains 12.4% of tannin, while green tea sample contained 2.8% of tannin, coffee contain 3.6% of tannin, and coffee sample 2 contain 4% tannin. So samples were taken was red label packet local brand tea, and Assam tea, and loose tea powder which was available in our area, and Lipton green tea as a green tea sample, and coffee Nescafe as a sample 1, and brew as a sample 2. So these are the this is the conclusion that the tannin content were studied, and it was found that it varies from 2.8 to 14.2%. So the lowest tannin content was observed in green tea as compared to the black tea.